Hello kids, welcome to JEE English Victory Batch. In this batch, we are covering class 11th's revision with some amazing concepts and one-shot lectures on the syllabus of class 11th. So today in this series, we are doing sets, relations and functions. So watch this session entirely and let's make most out of this session. In case you have not covered the chapters so far, then let me tell you beta, functions is a very important topic that you have to cover before moving into class 12th, because the entire calculus will be based on this particular topic. Okay, so let's start with definition of a set. A set is nothing but a well-defined collection of objects. Well-defined collection of objects is nothing but a set. Let's say if this is a kind of a set given to me, so it is having 1 as an element, 2 as an element, 3 also as an element. Yes or no? The symbol epsilon means belongs to. So if we are saying that 1 is an element of the set A, I can write that one mathematically as 1 belongs to A. Before this symbol belongs to, the element is written, and after this symbol belongs to, the set's name is written always. So if X is a member of the set A, then that will be written as X belongs to A in mathematics. So here we can say that 1 belongs to A, 2 belongs to the set A, and 3 also belongs to the set A. Yes or no? Yes. And also all the elements are written only once. Usually repetition of the elements is not done in sets. Yes or no? And sets are written with capital letters. Representation of set, if you see, there are two kinds of forms, roster form and another one is set builder form. So in roster form, if you see, elements are written in two curly brackets and the elements are separated by commas. Yes or no? Order of the elements is immaterial means what? Order of the elements is immaterial means the order does not matter. Order does not matter means which element is written first, which element is written later. It does not matter in a roster form. So if I want to write down the set A, I can also write it like this: 2, 1, 5, 4, 3. Both the sets are same only because order does not matter in a set. Yes or no of the elements, right? All right. So order of the elements is immaterial means it does not matter. I hope you are already aware of that. Okay, representation of a set in set builder form. Now in set builder form, we introduce one variable. So over here, this is a variable and this symbol means such that. Okay, sometimes such that is also written like this as well. Okay, sometimes such that is also written like this. This or this both means such that in mathematics. So X is a variable such that, and some property or rule is written over here. Some property or rule is written over here. Over here you can see that X is the natural number and less than or equal to 5. Now I hope that you know all the natural numbers 1, 2, 3, 4 and 5 and so on. But it is saying that X has to be less than 5. So the elements which will be satisfying these two conditions, property or rule, you can say, they will be nothing but 1, 2, 3, 4 and 5 only. Yes or no everyone? So in this form we introduce a variable, say X, representing any member of the set, followed by a property satisfied by each member of the set. Okay, each member of the set will be following that property, that rule or that condition, we guys can say. Okay, yep, that is what I have told you. All right, now empty set or null set, a set which is having no element in it, is nothing but an empty set. An empty set is represented like this or by this symbol psi, but not a combination of both. Either we will write down the empty set like this or like this, but not a combination of both. If I ask you the set of all real numbers whose square is -1, then you're going to get no real number for which square is -1. That means no real number is going to satisfy this rule. Hence, the set has to be a null set or empty set, or we can also call it as void set, right? Okay, the set of all rational numbers whose square is 2 is also a null set, because I know that two real numbers are there whose square, if we do, we get a 2. Yes or no? One of them is √2 and another one of that is -√2. So √2 and -√2 are not rational numbers. That's why you're going to get not even a single rational number whose square is 2. So this set is also going to be called as a null set only. Yes or no? I hope you guys are clear with this. The set containing even prime numbers, if you talk about even prime numbers, then I hope you guys know that one is neither prime nor composite. The smallest prime number is 2. The smallest composite number is going to be 3. Yes, composite number is a number which is having factors apart from 1 and the number itself. Right? I hope you know that definition. So, talking about the next set, and that is a singleton set. If the set is containing only one element, then that particular set is called as singleton set. If I talk about set containing even prime numbers, then the only even number which is also a prime number is nothing but 2. So the set will be represented like this only. As you can count down, the number of the elements coming inside is nothing but 1. Only one single element is coming. That's why we do call it as a singleton set. Also, if I ask you what kind of a set is this, a lot of guys do say that it is a null set. But let me tell you people, this is not a null set, because anything which is written inside the two curly brackets is going to be an element of the set. So here 0 is the element of the set, and how many number of elements are written inside the set? One number of element is written inside the set. So this is going to be a singleton set, not an empty set. Also, a lot of people do say that this is also a null set, but let me tell you, no, this is also a singleton set, because as I just told you, anything written inside curly brackets will be considered as an element. So for this set, phi will be considered as an element. So this is a single element written inside the curly brackets. So that's why we do call this set also as singleton set, people. Let's talk about this. Which of the following options is going to be an empty set? X is a real number and satisfying this. So over here you guys can see two values will come. So this is not going to be a singleton set, because this is having two numbers of element in it, that is x equal to 1 and x equal to -2. Here if you see, x is a real number satisfying this. So this equation has two roots. One is iota and another one is minus iota, which are not real numbers. Yes or no? So this is going to be a null set. Talking about this, over here you're going to get two values, 3 and -3. Both are real numbers. That's why this will not be your answer. And over here if you see this equation, then the roots of this equation are going to be x equals to 2 and -1. So these are two real numbers. So that's why two elements are written over here. So that's why this is also not a null set. So the answer is going to be B for Bombay. I hope you guys are clear with this particular question. There has to be no problem at all. Cardinality, or the number of elements coming in a set, or cardinal number. The number of elements coming in a set is nothing but the cardinal number of that particular set. The cardinal number of the set is written like this. Okay, if I talk about the cardinality of this particular set, it is having how many elements? So how do we count down the elements? Listen to me very carefully. If a set is written like this, let's say 0, 2, 4 and then bracket closed, just remove the two curly brackets which are written outside first. Just remove them. Now you have to see the elements are separated by commas. Yes or no? So this is one element, this is second element, this is third element. So how many number of elements are written? 3 elements are written. That's why we say that the number of elements in the set are 3, or its cardinality is equal to 3, or the cardinal number of the set A is nothing but equal to 3. Okay, finite and infinite set. A set which contains finite number of elements is a finite set, and the set which contains infinite number of elements is an infinite set. If I talk about X is such that X belongs to first 100 natural numbers. So this set can also be written like this, bacho. So how many elements this set will be having? It will be having 100 elements in it, which are definitely countable. So this is a finite set. Yes or no? Okay. X belonging to integers such that X is greater than 2. Can you tell me the integers which are greater than 2? So they are going to be 3, 4, 5, 6, 7 and so on. So definitely it will never end. So we can say that number of the elements in this particular sets cannot be counted, and that's why it is an infinite set. Universal set is represented by U or the symbol mu. Universal set is generally given to me in the problem. If you have studied class 11, then I think you have already fairly good idea about this. So don't worry about universal set, but let me tell you one thing about universal set over here, and that is whatever elements we are dealing in the problem, whatever elements we are dealing with in the problem, they has to be there in the universal set. Because whatever I am doing on the earth, am I also doing that in the universe as well? Because earth is just a single part of universe only. So feel it like that. The universal set is a set containing all the possible elements given to you in a particular problem will lie in the universal set. So this will be given to you in the problem. You need not to worry about that. Okay. If A set is given to us like this 2, 4 and B is such that it is a solution of this particular thing. So can we guys find out the solutions, everyone? So we can see that the two solutions are going to be -2 and -4. So set B can also be written as -4, -2, yes or no? So the sets A and B are going to be null sets? No, because both of them are having two elements. Are they going to be singleton sets? No, because they are having two elements in it. Equal sets are the sets in which exactly same elements are there. Exactly same elements are there. So are the two sets A and B having exactly same elements? No sir, this is having 2 and 4, it is having -2 and -4. So exactly the two sets are not having exactly same elements. So that's why these two are not exactly, these are not equal sets. And disjoint sets are the sets in which there is nothing in common. So as we can see that these two sets have nothing in common, that's why these are going to be nothing but disjoint sets. Yes or no, everyone? So disjoint sets are the sets in which nothing is common. Yes or no? I hope you guys are aware of this. Talking about types of sets, equal sets are the sets in which exactly same elements are there. Exactly same elements are there. Like A set is given to you A comma B. Okay, let me tell you over here only example. If let's say A set is given to me like this A comma B and B set is given to me like this B comma A, are these two having exactly same elements? Yes, so they will be called as equal sets. Equivalent sets, sets having same cardinality, sets having same cardinality are known as equivalent sets. Sets having same cardinality. If we talk about a set A, let's say A comma B, and another set B being 1 comma 2. So are these two sets having same cardinal number or not? Yes, that's why we do say that these are equivalent sets. Talking about subset, if whatever A is having, if it is also there, in B, then we say A is a subset of B. A is a subset of B. We write down this statement mathematically as A is a subset of B. For example, if we see, let's say A set is A comma B and B set is A comma B comma C comma D. So can you see that whatever A is having, A set, small a, it is also there in B, small b, it is also there in B. So can we say that whatever set A is having, it is also there in set B? Yes, that means A is a subset of B, and mathematically we write down that statement like this. Understood? Okay, talking about superset, if A is a subset of B, if A is a subset of B, then B is a superset of A. Then B is a superset of A. It is as simple as that. So over here, can we say that B is a superset of A? Therefore, we can say that this statement B is a superset of A in mathematical terms will be written like this. B is a subset of A. I hope you are clear with all the terms coming over here on the slide. So equal sets, as I have just told you, two sets A and B are said to be equal if they do have exactly same elements. Equivalent sets if they have same cardinality. If we talk about an example of the following things, then let me tell you, if A set is given to me like this, B is given to me like this, so these are having same cardinality but not same elements. So these are equivalent but not equal sets. And if we talk about these two sets, these are having same cardinality and same elements. That's why we do call them as equivalent and equal sets. Let me tell you, if sets are equal, then they will be equivalent as well. They will be equivalent as well. But not vice versa, but not opposite. Okay, remember this statement as well. Subset, as we have just seen, a set A is called a subset of B if and only if all the elements of A are also in B. Subset is usually represented like this. So here A is a subset of B, as you guys can see. If this is A set, this is B set, whatever A is having, it is also there in B. Yes, that means we say that A is a subset of B. A is a smaller set over here, B is a bigger set. So smaller set is a subset of bigger set, as you can see over here. And bigger set is going to be superset of smaller set A. Bigger set is going to be superset of smaller set. So if A is a subset of B, then we said that B is a superset of A. I hope you guys are clear, and the symbol is like this. So if you want to say then B is a superset of B, in mathematical terms it will be written like this. I hope you guys are clear with this. Talking about a few true and false over here, I told you that this symbol also means such that. So x is such that x square plus 1 equal to 0, and x belongs to a real number. So from here you're going to get two solutions, plus iota and minus iota, but it is saying that x also needs to be a real number, which is not over here. So is this going to be a null set? Yes. So this is a true statement. Yes or no? Okay. Is this a null set? No, it is a singleton set rather. So this is a false statement. X is such that x is the smallest natural number. Smallest natural number means the set can be represented like this. So is it a singleton set? Yes, because the number of elements written inside is nothing but 1. Okay. Now 0 belongs to a set phi. As I told you, this will be considered as an element. Before the symbol belongs to whatever is written, that has to be an element, and whatever is written after the symbol belongs to or epsilon has to be a set. Yes, so a null set has nothing in it. So can we say that this is going to be a null set? I think no, because 0 is nothing but an element of this particular set. So is this statement going to be true or false? So this statement is going to be a false, because this means that 0 always will be an element of a null set. No, this is not possible, because a null set contains no element. Okay, talking about this, is this a singleton set? Yes, because phi will be considered as an element of this particular set. Yes or no? So these are the answers that I have just told you. I hope you guys are clear with these fundamental things. Okay. Null set is a subset of every other set. Do remember this statement. Every set is a subset of universal set, and every set is a subset of itself. These are few important things that you should always keep in your mind, kids. Okay. Talking about a few things, if I ask you, if let's say a set A is given to you like this, 1, 2, 1, 2, can you tell me what is the cardinality of this particular set A? The cardinality of this particular set A is going to be how much? The cardinality of this particular set A is going to be how much? The cardinality of this particular set is going to be 3. Let me tell you why. Because I told you a rule. Remove the two outside curly brackets first. Okay, Then elements will be separated by comma. So this is one element before this comma. This is another element. And after this, if you see, this will be considered as a single element. This will be considered as a single element. Why? It is because you have to see that this particular thing is opening. This curly bracket is here. Then this curly bracket has to close as well. You can feel as of now like this, but this will be considered as a single element, because if you have studied power set, then I think this is easy for you to understand. So this will be considered as a single element, because over here, if it is this bracket is opening from here, then it has to close as well over here. So that will be considered as a single element. So the cardinality of this particular set will be considered as 3, not as 4. Okay, so the cardinality is 3. Alright, x is such that x is a positive factor of a prime number p. P is a prime number given to me. Now any prime number do have 2 factors in it. Yes, 2 factors in it. What are the 2 factors? The 2 factors are 1 and the number itself. 2 factors, and the 2 factors are 1 and the number p itself. So is it going to be a null set? No, it is having 2 elements in it. Singleton set? No, elements are having 2. Finite set? Yes, absolutely. Infinite set? No. I hope the question is clear to all of you guys. Yep, so the correct answer of this problem is going to be C for Calcutta. Alright, x is such that x is a real number and x square equals to 16 means x can be either equal to plus 4 and minus 4. So A set can be written as 4 and minus 4 being the 2 elements in it. And also, okay, no, I haven't done the problem complete yet. Okay, and also it is saying that 2x equal to 3 means x equal to 3. Okay, in between and is written means we have to take intersection. So we have to take the common values coming in these two. So there is no such value which is also lying here and here. So A is going to be a nothing but a null set. Yes or no? So the answer is going to be A for Arvind sir. Yes or no? Anyone is having any issues? Do let me know. And means intersection. Intersection means common. Common. If in place of and, let's say or is written. If in place of and, let's say or is written, then in that case the set A would have been looked something like this. Okay, if in place of this, if or is written, then the answer would have been this, because our set A would have looked something like this. I hope you guys are clear with this particular question. Anyone is having any kind of issue, feel free to reach out to me. There has to be no issue at all. Okay, let's say set A is given to me theta such that sine theta is always equal to tan theta. Sine theta is always equal to tan theta. Let me ask you about this. So over here, if you see, the problem can be written as something like this, because tan theta can be written as sine theta over cos theta. The moment we take sine theta common, so what we will be having? We will be having 1 minus 1 by cos theta equal to 0. Yep. So over here, two things can be there. Either sine theta is equals to 0 or cos theta is equals to 1. Sine theta is equals to 0 means theta is equals to n pi, and cos theta is equals to 1 means theta is equals to 4n plus 1 pi by 2. Yes or no? Everybody do let me know where where n is an integer. Here n is an integer. N belongs to an integer. Anyone is having any issues? I think you might have learned this thing in trigonometry. Yep, talking about this, if sec theta is equals to 1 means cos theta is also equals to 1, and if cos theta is equals to 1 means it is equal to 4n plus 1 pi by 2, where n belongs to an integer. Yes or no? Okay, then it is saying that B is not a subset of A, but let me tell you guys, I hope you can easily feel this, that B is nothing but a subset of A. B is a subset of A or not? Do let me know, people. Do let me know. Yes, B is a subset of A. Right? Yes. So this is not our answer, because B is a subset of A. Can you guys feel that B is going to be nothing but a subset of A? Yes. A and B are equal? No, not at all. A is a subset of B? No. A is not a subset of B? Yes, definitely, because rather B is a subset of A. I hope you guys are clear with this particular problem. Okay, so the answer is going to be D for Delhi. I hope you guys are clear with this. Power set. Let's say a set A is given to me like this. And let me tell you one important concept over here. If a set has n number of elements in it, then total number of subsets of that set will be 2 to the power n. Means a set A is given to me, let's say, having 3 elements in it, then the number of the subsets of A will be nothing but 2 to the power 3, that is equal to 8. If let's say a set is given to me having cardinality as 4, then the number of subsets which can be written for that particular set will be 2 to the power 4, that is equal to 16. 16 subsets you guys can write down if that particular set is having 4 elements in it. Yes or no? Okay. So now as you can see that if the cardinality of the set is 3, then number of the subsets that can be written is 8, and let me write down those subsets now. So one of them is going to be a null set, because null set is always a subset of each and every other set. Another subset is going to be only one element, that is 1. Another subset is going to be having only one element, that is 2 this time. Another subset will be having only one element, having only 3 in it, then having two elements, 1 and 2 together, 2 and 3 together, 3 and 1 together, and then 1, 2, 3, that is the set itself. So if these are the 8 subsets written, if I put these 8 subsets as elements and putting it into 2 curly brackets, I do get nothing but the power set of A only. So what am I trying to tell you over here is subsets of A are elements of power set of A. Power set of A is again a set, and for that elements are nothing but subsets of A only. The number of subsets of A is equal to number of elements of power set of A. Number of elements of power set of A. I hope you guys are clear with this. Yes, a very important thing. Now, how does this formula comes 2 to the power n? It's from permutations and combinations. I hope that you people have already gone through permutations and combinations. For let's say I want to write down any subset of A. For this element, I will be having 2 choices, either to take it or not to take it. So 2 choices for the element 1, 2 choices for similarly for the element 2, 2 choices similarly for the element 3, and each and every element is independent of the another. Yes or no? Whether in the subset I take 1 or not, it does not matter whether I'm taking 2 or not, it does not matter whether I'm taking 3 or not. Yes or no? So that's why we do multiply. So over here you guys can see 2 to the power 3 is coming. So that's how we get the formula for number of elements in a if number of elements in a set are given to us as n, then the number of subsets of that particular set will be nothing but 2 to the power n. Also over here subsets of A are nothing but elements of power set of A only, and also number of subsets of A is nothing but equal to number of elements in the power set of A only. I hope you guys are clear with this. Okay, talking about this. If A is a set given to me like this, having cardinality 1, only one element is there, can we guys find out power set of A? Okay, in order to find out power set of A, we first need to write down subsets of A. Let's write down the subsets of A. How many number of subsets of A will be there? The cardinality is 1, so 2 to the power 1, that is equal to 1 only. So 1 will be null set and another one will be the set itself. Yes or no? I said fine. Okay. So how the power set of A will be looking like? These elements, these subsets will be considered as an element. So this is nothing but our power set of A. Let me call this as another set B, let's say, and if I want to write down power set of B, so power set of B will be nothing but this. Okay, this time these two will be considered as an element, yes or no? So if B set is having 2 elements in it, the number of the subsets of B will be 2 to the power 2, that is equal to 4, yes or no? So if I want to write down this, for that let me write down subsets of B first. Subsets of B will be what? Subsets of B will be, one of them will be null set, one of them will be having an element psi in it, one of them will be having element 1 in it, and one of them having both the elements like this. Yes or no, everyone? So if I want to write down power set of B, I'll put all these elements inside the two curly brackets. So this is going to be my power set of B. Anyone is having any issue in this, feel free to reach out to me. Yes or no, beta? Yep, let me close the bracket. So this is how our power set of B will be looking like, and power set of B is nothing but power set of A. So this is nothing but power set of A. So how many elements power set of A is having? 4 elements. I hope you guys are clear with that. Anyone is having any issues, do let me know. Okay, let me tell you a few very important things over here. If A has n elements in it, then number of elements in power set of A will be how much? 2 to the power n. I said okay. Okay. Number of elements in power set of A will be how much? Can you tell me, beta? 2 to the power n. Yes or no? Okay. Number of elements in power set of A will be how much? Can you tell me, beta? 2 to the power this. Yes or no? These are going in the power. This is a very important thing. I hope you guys are clear with this. It's a very important thing. You can take an example. Let's say A is having 1 element in it. So power set of A is having 2 elements in it. Because 2 to the power 1, number of elements will come in power set of A. If power set of A is having 2 elements, so number of subsets of this will be 2 to the power 2, that is 4. So power set of A will be having 4 elements in it. If number of elements over here are 4, then the number of subsets will be how much? 2 to the power 4, that is 16. So 16 number of elements will be there in the power set of A. If power set of A is having 16 elements in it, then 2 to the power 16 number of subsets you can write down for that set. So the number of elements in power set of A will be 2 to the power 16. So that is what the formula I have just told you people. I hope you guys are clear with this, and you guys can have a look at these solutions as well, because these are written very neatly over here. So as I just told you, if a set is having n number of elements in it, then number of the subsets of that particular set A will be nothing but equal to 2 to the power n. If a set S is having 4 elements in it, then the number of elements of that particular set A will be nothing but 2 to the power 4, that is equal to 16. Also, we can say that the cardinality of the set S is 16, and the number of elements in power set of S will also be 16, because all the subsets of S will be nothing but elements in the power set of S only. Yes or no, everyone? Okay, now talking about Venn diagrams. Venn diagrams very important as far as JEE is concerned, because these same things will be used in permutations and combinations as well, in probability as well, in mathematical reasoning as well. So it's very important that we do master these things, because these are going to be very important, people. Okay, talking about universal set and elements, I hope you know these basic things. Here we can say if this kind of a diagram is given to us, then A is going to be a subset of B only. Yes, because A is completely inside B only. Over here we can say that A is going to be superset of B, B is going to be superset of C. So the diagram is going to look something like this. Yes or no, everyone? Okay, union of two sets. Okay, union means write every value once. Union means write every value once. Okay, if let's say A is given to me like this, B is given to me like this. Now if I am saying write down A union B, then A union B is going to be what means, kids? Write every value once. So 1, 2, 3, 4. We have written all these values first, and then 3 we have already written, 4 we have already written. Write down 9. So write every value once is nothing but A union B. I hope you guys are clear with that. Okay. And in Venn diagrams, if you see, if this is our set A, this is our set B, then A union B means this region, and this region. So remember this particular Venn diagram, A union B will be represented like this. I hope you guys are clear with this particular thing. Let me tell you one thing, that A union B and B union A are both equal always. Note, this is a very, very, very important thing. I hope you people are already aware of this. A union B and B union A are always equal. If you take union of A with itself, then you have to write down every value once, means it has to be A set only, yes or no beta. Okay, if we talk about A union B union C, then let me tell you kids, you guys can deal with 3 sets by using this particular diagram. Okay, yes, this is set A, this is set B, and this one is set C. Okay, very important thing that you have to remember over here is there are 8 independent regions that do come in this particular diagram. Yes, these are the 8 different regions which are important for you guys. And also, if you deal with 2 sets Venn diagram, then the Venn diagram will be looking something like this. Over here you do have 4 regions, kids. Let's say this is set A, this is set B, then over here you do have 4 different regions, 1, 2, 3 and 4, okay, 4 different regions. So these Venn diagrams are very, 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 very important, and by these Venn diagrams you guys can solve these problems quite comfortably, okay. Do remember that everywhere if union is written, then it is associative, it is kind of an associative, okay, associative. Yes, if we first take union of these two, or if we first take union of these two, it does not matter. If everywhere union is written, then the thing is going to be same. Okay, if and this set is nothing but universal set. I hope you guys are aware. Okay, over here this one is universal set. Okay, so what is the union of a set A with its universal set? Entire universe, yes or no? Okay. What is the union of A with null set? A only. Yes, if A is a subset of B, then in that case the Venn diagram will be looking something like this. This is our universal set, this is set B, let's say, and this is our set A. So this is set A, this one is set B. So if A is a subset of B, then the value of A union B is nothing but equal to B only. I hope you guys can easily identify these things in your mind. Okay, talking about intersection of sets. Intersection means write common values between A and B. Write common values between A and B. Okay. Yep. Let's say a set A is given to you like this, and a set B is given to you like this, and you want to write down A intersection B. So what are the common values coming in A and B? 3 and 4. So A intersection B is nothing but this. And in Venn diagrams, if you see, A intersection B can be represented by the common region which is lying in the circles A and B. Let me tell you that this is circle A, set A, and this is set B. Then the common region, the overlapping region of the two sets is nothing but A intersection B people. Right? I hope you guys are clear with this. Okay. As I told you earlier that this is having 4 different regions. So let me tell you, this 4 region diagram denotes all the possibilities which can be there while dealing with two sets. It includes all the possibilities, okay, all the possibilities which can be there while dealing with two sets. Okay, let me tell you one more thing over here. If A and B are having something as common, let's say, then B and A will also be having the same things in common or not. So A intersection B and B intersection A are both same. This is what I want to tell you guys. I hope a lot of guys already do remember this particular thing. Okay, so number one thing, A intersection B and B intersection A are same only. Okay, what do A and A have in common? I think only A. Yes, if I first take B intersection C and then take that thing's intersection with A, or I first take A intersection B and then take intersection with C, ultimately the thing is going to be same only, because ultimately I am taking common values, common elements in A, B and C, common elements in A, B and C. Yes or no? So the element has to be common in all three of them. So it does not matter whether you are taking first elements common from here or here, ultimately you are taking the elements which are lying in A as well as in B as well as in C. Yes or no? Okay. Talking about this, let's say this is my universal set, and if over here A set is written, what do this A and universal set and A having in common? I think only set A. Okay. What do a set A and a null set have in common? I think nothing in common. Okay, if A is a subset of B, then let me tell you that the diagram will be looking something like this. This is A and this one over here is B. If A is a subset of B, then what do A and B have in common? I think set A only. So that is what written over here. I hope you guys are clear. If any two sets A and B have nothing in common, or their A intersection B is phi, we say that the two sets are nothing but disjoint sets. And in the case of that, the Venn diagram looks something like this. This is set A and this is set B. They do have nothing in common. That's why there is no overlapping region. I hope you guys are clear with what I have taught you so far. Okay, let's do a few problems based on this. X is a prime factor of 240. Okay, prime factor of 240. Let me factorize 240. 2 will come over here. This is 120. This is 60. This is 30. This is 15. This is 3. This is 5. And this is 1. Okay, so the prime factors of 240 are nothing but 2, 3 and 5 only. Prime factors I am talking about. Number of factors I am not talking about. Number of factors I hope you have seen in permutations and combinations. Okay, X is the sum of any two prime factors of 240. Now we do have the two prime factors as 2, 3 and 5, and B is all those values of X such that X is the sum of any two prime factors. So either it can be a sum of 2 and 3, either it can be a sum of 3 and 5, or either it can be a sum of 2 and 5. Yes or no? So the set B will be looking something like this. Yes or no? Look at the definition of the set B, then you will have an idea that why we have taken the elements like this. Okay, now if this is our set B, what do A and B have in common? I think 5. So this is definitely not our answer, because A intersection B is what? Is equal to having element common 5. So 5 does not belong to A intersection B. This is wrong. 8 belongs to A intersection B. No, this is wrong. If you talk about A union B, then A union B will be written as how? 2, 3, 5, 7 and 8. Yes or no? Union means write every value once. So 8 is belonging to the set A union B. That's why D for Delhi is going to be our answer. Anyone is having any confusion in this? Feel free to reach out to me, people. There has to be no issue at all. Okay, talking about this, if X, okay, let me put curly brackets over here first. Okay, now this is a circle, isn't it? Okay, X and Y, such that this is the case. I said fine. Okay, so X is a circle having center at origin and radius equal to 5. Yes or no? You might have studied this topic, circles, in class 11th, right? Okay, so let me plot a few points over here. Okay, so this is what your A set is looking like on the boundary, and this is an ellipse. Yes or no? If we talk about this ellipse, then let me tell you it is x square over 144 plus y square over 144 by 16 is equal to 1. So we can write down this ellipse as x by 12 ka whole square plus y square by this is 12 over 16. So I think this is 9. So 9 can be written as 3 square. Yes. So this ellipse will be written like this, beta, is equal to 1. So if you draw this ellipse, you guys can feel that the ellipse will be coming out to be somewhat like this. The ellipse will be looking somewhat like this. Yes or no, beta? Okay, so this point is 12, 0. This point will be minus 12, 0. this point will be 0 comma 3, this point will be 0 comma minus 3. I hope you guys can draw the diagram of this circle as well as this ellipse, yes or no? Okay, so A intersection B is having how many points in common? How many points in common? This is one common point, this is another common point, this is third common point, this is fourth common point. So A and B, A intersection B contains 4 points. Yes or no? Everyone do let me know. Yep. All right, moving on to the next thing. I hope the problem is clear to all of you guys. It's based on simple geometry, based on problem based on simple geometry, based on simple geometry. As you might have seen that JEE is asking a lot of questions based on this particular concept these days, so you should be clear with the geometrical terms. Difference of sets, let's talk about that. It's a very easy thing. Let me tell you, A minus B is remove those things from A which are also in B. Remove only those things from A which are also in B. Okay, that is nothing but A minus B. Okay, set A is given to me like this, set B is given to me like this. Remove those things from A which are also there in B. Okay, do we need to remove 1? No, 1 is not there in B. Do we need to remove 2? Yes, 2 is there in B, so remove it. Do we need to remove 3? Yes, 3 is also there in B, so remove it. Okay, do we need to remove 4? No, because B is not there in B. So what we are left out with? We are left out with 1 and 4, so that is nothing but our A minus B. Let me tell you this thing once again. A minus B means remove those things from A which is also there in B. That's it. A minus B. Okay. On the same pattern, B minus A is going to be what? B minus A is going to be remove those things from B. Remove those things from B. From B which are also in A. Which are also in A. Which are also in A. So this time we have to take set B. Do we need to remove 1? Yes sir, 1 is also there in B, A, yes, remove it. 3, do we need to remove 3? Yes, because it is also there in A, remove it. Do we need to remove 7? No sir, because 7 is not there in A. So B minus A will be looking out like this. I hope you guys are clear with this particular thing. Everyone, there has to be no issue at all. So I hope you guys can observe over here, A minus B and B minus A are not equal. Yes, so unlike A intersection B and B intersection A, these two are not equal. Okay, let me tell you that A minus B is represented like this in the Venn diagram. A minus B is same as only A. A minus B is same as only A. Only A. Understand? This entire region is A. This entire region is A, and in this region A, two things are there. In this region A, two things are there. One is only A. One is only A, this one. And another one is this, B as well. Not just A, but B as well. Are you getting my point? So A region is consisted of these two things. Only A, and the region not just A, but B also. So if I am talking about only A is same as A minus B. Okay? Alright, talking about this is B minus A. B minus A is the same as only B. B minus A is same as only B. Because if you look over here as well, B is consisted of two regions. Only B, the one that is already shaded, and this one, not just B but also A. So B is consisted of these two things. This red one is not just B but also A, and this horizontal lines is the region only B. So only B is same as B minus A. Do remember this thing. Alright, talking about the next thing. Okay, let's talk about this. A minus A. Remove those things from A which are also there in B. That means you need to remove everything, yes or no? Is it going to be a null set? Yes. Remove those things from A which is also there in the null set. Null set does not have anything, so that means you don't need to remove anything. Remove everything from A that is there in the universe. Okay, remove everything that is there in the universal set means you have to remove everything, because all these things that A is having, it is also there in universal set, so that means you need to remove everything. So that's why null set. right? A minus B intersection C. Now you can split it. I hope you can easily visualize this. There has to be no issues, or you can see it through Venn diagrams. There will be not a difficulty. Venn diagrams. Let me tell you through Venn diagrams how we're gonna do it. I have told you that the Venn diagram for 3 sets will be looking something like this. This is set A. This is set B. And over here is the set C. Right? Okay. If I'm talking about B intersection C, okay, talking about fourth part first. B intersection C, that means the common values in B and C is this, the green one. Okay. And if I'm talking about A minus B intersection C, that means A minus B intersection C. Let me tell you that thing. A minus B intersection C. That means you need to remove that portion from A, which is also there in B intersection C. So the region left out is going to be this. The region left out will be this. Yes or no, people? Is this going to be the left hand side or not? Is this going to be the left hand side or not? Yes or no? Remove that thing from A. So you have to remove portion from A only. Yes sir. Number 1. Number 2, that is also coming in B intersection C. So you can see over here that this region, this smaller region is coming in B intersection C. So you need to remove it. I said okay. Talking about this right hand side part of the fourth problem, let me draw a Venn diagram over here. This is set A, this is set B, let's say, and over here is set C. Okay, so let me write it down. This is set A, this is set B, and this over here is set C. Okay, A minus B, that means remove the portion from A that is also there in B. So that means you have to keep this one. You have to keep this one. Yes or no? Have a look at this, everyone. A minus B, that is remove the portion from A which is also coming in B. So you have to keep this one. I said fine, okay. Okay, so over here union is written. Okay, and talking about A minus C, if you talk about A minus C, then A minus C will be this region. Have a look at this. Is this going to be A minus C or not? Everyone have a look at this. Okay, so let me shade it now. Now if union is written in between, that means even if a single color is there out of green or red, you have to take that region. Yes or no? Even if out of red and green, if a single color is shaded, you have to take that region. So I said fine, you have to take any one color's region. That means you can say that this entire region is going to be your right hand side now. So are these the two sides coming equal? Have a look at this. Hence proved. Fourth one. If you don't want to prove it like this, then let me tell you, A minus B intersection C. Let me tell you another method as well. A minus B, over here union, and over here A minus C. This is the formula, right? You can prove it in another way as well. Let me tell you the another method as well. This method is relatively way easier, and this will be used in mathematical reasoning as well as in probability as well, and in other chapters as well, like P and C. Okay, this is a fairly easy one. Let's say this is set A, this is set B, and this is set C. Okay, let me call down a few numbers over here of the different regions. These are the 8 regions. If I talk about set A contains what region? Set A contains region 2 plus region 3 plus region 5 plus region 6. Yes or no? Set B contains what region? Set B contains region 3 plus region 4 plus region 6 plus region 7. Okay, set C contains what? Region 5 plus region 6 plus region 7 plus region 8. Yes or no, everyone? Okay. If I talk about B intersection C, can you shade it? B intersection C is going to be region 6 and region 7. Yes or no, everyone? Do let me know. If I tell you to write down A minus B intersection C now, so you have to see over here, region 2. Do you need to remove region 2? No sir, it is not coming in B intersection C. So keep region 2, okay. Do we need to remove region number 3? No sir, it is not coming in region B intersection C, so we need to keep it. Do we need to remove region 5? No sir, it is not coming in region B intersection C, so we need to keep it. Do we need to remove region 6? Yes sir, region 6 is not coming in B, is also coming in B intersection C, so we need to remove it. So this is what our A minus B intersection C will be looking like. I said fine, okay, let's talk about A minus B. If we talk about A minus B, then do we need to remove region 2? No. Do we need to remove region 3? Yes sir. Do we need to remove region 5? Do we need to remove region 5? No sir. Do we need to remove region 6? Yes sir, it is also coming in B. So A is nothing but region 2 plus region 5. I said fine, okay. C, okay, A minus C if you see, A minus C if you see, do we need to remove region 2? No sir, it is not there. Do we need to remove region 3? No sir, it is not there. Do we need to remove region 5? Yes sir. Do we need to remove region 6? Yes sir, because it is also there in C. So our A will be looking something like this, region 2 plus region 3. So if you take union of these two, A minus B, union A minus C, if you do, it is going to be nothing but write every region once. So region 2 plus region 5 plus region 3, because union means write every value once. So this and this, are these two coming things, are these two things coming equal? Yes sir, region 2, 5 and 3, region 2, 5 and 3. So that means these two expressions are equal, hence proved. So this method is going to work every time. Instead of shading, I recommend this method, because shading regions sometimes is not that easy, because kids do make mistake over there, but I don't think in this regions you're gonna make mistake anywhere. So the proof we have already done just now only. I have attached the proof for you guys. The shaded regions are there, so you guys can easily visualize it, and you guys can have a look at this and understand it quite easily. Okay, there has to be no issue at all. Complement of a set, we need to deal with complement of a set. Now the set which contains all the elements except all the elements that are in A. Okay, that means A dash or A to the power C is nothing but A complement, and A complement is A complement is nothing but rather this universal set minus A. That means remove all elements from U which are also in A, If you see it in Venn diagram, then from the universal set we need to remove that portion which is there in the set A. So that means we need to cut this portion, this circle from the universal set. We will get nothing but A complement only. So A complement is this region outside the circle A, this region. I hope you understood A complement. There has to be no issue at all. Okay, can you tell me what exactly is common in A complement and A? Sir, they do have nothing in common. Okay, what is the union of these two? Is it going to be the entire universal set or not? Can you guys feel these two things? Do let me know, right? Okay, let me give you an example as well. If A is given to me like this, and let's say universal set is given to me like this, so what is going to be my A complement? A complement is going to be 3, 4 and 5. That is everything except the elements which are lying in the set A. I hope you guys are clear with that. Okay, talking about this, union is going to be universal set, their intersection is nothing in common. The complement of universal set is going to be nothing but null set, yes or no? Because if I tell you that this is a universal set and remove this entire universal set, that means nothing will be there. Okay, what is the complement of a null set? The entire universe, yes or no? Universal set will be there, sign. Okay, A minus A complement, since these two have nothing in common, so entire A will remain or not. Or if I ask you what is A complement minus A, don't you think that A complement will come, because A complement and A have nothing in common? That means we don't need to remove anything from A complement over here as well. So A complement will be the answer. De Morgan law, this is very important. Do remember this. If you are not able to remember this easily, then let me tell you a trick by which you can remember this. A intersection B is complement. Now Morgan is a good English cricket team player. So what he does is he gives compliment to the bowlers first, that you guys are very good bowlers, and then he nail them so much that they forget their line length. Yes or no? So let's say A and B are bowlers. So first Morgan is going to give them compliments. So A compliment, B compliment, and then he will hit them so hard that their line length is going to change. That means if intersection is there, it will become union over here. If you follow the same logic, then A union B's complement is going to be what? First Morgan is going to give compliment to both the bowlers, then he gonna hit them so hard that their line length is going to get changed. So if union is there, it will become intersection over here. So these are the two formulas, De Morgan laws. You guys can prove it through Venn diagram as well. There has to be no issue at all. Prove it through Venn diagrams, and in Venn diagrams I have taught you two approaches, either by shading or by writing down the regions. Symmetric difference. Symmetric difference's symbol is delta. If I have been asked A delta B, that means I have been asked A minus B union B minus A. If you remember, we have talked about this, that this is nothing but only A and this is nothing but only B. So what will be the union of these two? Both the regions we have to write down. And if I ask you one very important thing over here, what is the intersection of A minus B and B minus A? They do have nothing in common, isn't it? So that is going to be a null set. So A delta B is represented by this region and this region. So you must remember this. This one is A minus B, this one is B minus A. Taking the union means write every value 1, means we have to write down both the regions. Yes? Okay. A minus B union this, I think you guys can prove this one quite easily since two sets are there. So we need to draw two diagrams, two set diagrams. So let's say this is our set A and this is our set B. Let's say this is set A and this is set B. Okay, A minus B union B minus A, as we have just seen on the left hand side, is going to be this union this. So this is my left hand side. And if you talk about right hand side, then the right hand side will be looked at as how? Okay, let me draw the first sets over here first. This is set A and this is, let's say, set B. So A union B is going to be how much? A union B is going to be this, this and this. From here we need to remove A intersection B. Okay, so this is what we need to remove. So don't you think that we are left out with the same regions only? Hence proved. One way is this. Another way is, as I have told you earlier as well, method 2. Okay, if we take a Venn diagram like this, these are the two sets. Okay, let me write down the regions 1, 2, 3 and 4. Let's say this is set A and this is set B. So set A consists of region number 2 and 3. Set B consists of region 3 and region 4. Okay, if you have been asked A minus B, so A minus B is going to be nothing but R2, yes or no? Because R3 has to be removed. Okay, if you talk about B minus A, R3 has to be removed, it will be region 4 only. Now A union B is how much? A union B is region 2 plus region 3 plus region 4. And A intersection B is going to be what? Region 4. So if you need to remove from this region, region 4, region 2 and region 3 will come. And if you take the union of these two, region 2 and region 3 will come, region 4 will come. Wait, it will be region 3 over here. Yes, so from here also you are left out with two regions, region 2 and region 4, and here also you are left out with two regions, region 2 and region 4. So hence proved. I hope you guys are clear with this. I have attached this Venn diagram for you guys. Refer Venn diagram if you want to understand it neatly. I hope you guys are clear with this. Okay, let's talk about this question. If you are not able to solve these kind of problems, then let me tell you, we have covered such variety of questions in basic mathematics session in the Victory batch itself. Mod x less than 2, I have told you that ultimately the distance from 0 that you have to travel should be less than 2. So if you are standing over here and you have to travel a distance less than 2 from this 0, so that means you can reach till this 2 but not 2, And if you are traveling in the left hand side direction, then let me tell you, distance is always positive. So in the left side also you guys can travel. So over here, the solution of this equation is going to be x belonging to minus 2 to 2. And if you talk about this, whenever you comes across such kind of a thing, I told you that whatever is written inside the modulus, you need to take it as t. So put x minus 2 is equals to t. The problem will be like this. Now here you have to travel the distance more than or equal to 3. That means here you can travel more than 3. There you can travel beyond minus 3. So ultimately it is going to be t less than or equal to minus 3 or t greater than or equal to 3. T is nothing but x minus 2. So let me put it over here. So over here you can see that x has to be greater than or equal to 5, and from here you can say x has to be less than or equal to minus 1. So our B set will be nothing but this particular thing, minus infinity to minus 1 union 5 to infinity, people. Yes. Okay. Now if A set is given to you like this, minus 2 to 2, and B set is given to you like this, minus infinity minus 1 union 5 to infinity, can you write down these A minus B, B minus A union B, and A intersection B? Let's see this. First, let's write down A union B, people. Union means write every value once. Yes or no? Let me draw a number line first. Okay. So somewhere over here 0 will come, then 1, then 2, then 3, then 4, then 5, then 6, and so on. Over here minus 1, minus 2, minus 3, minus 4 will come, and so on. Okay. I'm shading this particular thing with this. So minus 2 to 2, will be this region. I said okay. And I'm shading this particular thing with a white one. Okay, this one with a white one. Okay, so I hope this is visible to all of you guys. Minus infinity till minus 1, including minus 1. Okay, and 5 till infinity. So this is there. If we have to take down union means we have to write down every region once. Okay, so let me shade it on the number line itself. This region we have to take. Okay, minus 2, though it is not coming over here, but it is coming over here, so we need to take minus 2 as well. Minus 1 is coming here as well as here. We need to take it only once. I said fine. Okay, minus 1 is also there. Okay, then this region is coming in the above line, so in the union we have to take it. But 2 is not coming here as well as here. That means we don't need to take 2. Okay, then 2 to 5, no value is coming either here or here. So here we have to take 5 and onwards. So the union of these two things is coming out to be what? It is coming out to be minus infinity to 2 union 5 till infinity. This is our union. I hope you guys are clear with this. Okay, talking about the intersection part. Beta. A intersection B. Let's talk about this. Let's draw a number line, or over here only we can see what is the common region coming in these two. The common region is coming out to be between minus 2 and minus 1. Minus 1 is common. Have a look at this. But minus 2 is not common. Okay, and then I don't think any other value is there. So it is going to be minus 2 open, but minus 1 closed. Yes or no, everyone? Okay, let's talk about third thing. That is A minus B. A minus B means from this region we have to remove those values which are also coming in B. So that means from this region we have to remove this A intersection B. So ultimately you will be left out with what? You will be left out with minus 1 say open 2. Yes or no, everyone? Have a look at this. From this region we need to remove the common region. So we need to remove this much region. So we are left out with minus 1 say 2. Okay, fourth one, B minus A. We need to remove from this the common regions. So minus infinity till minus 2 will be there. Okay, we don't need to remove minus 2. So minus 2 will come over here. And over here also we need to keep it 5 till infinity. Not an issue. So these are the four things coming. Minus infinity say open minus 2 union closed 5 to infinity. This was our A union B. So let me tell you this. A minus B is coming out to be minus 1 say -1 say open to. So this is not our answer. If we talk about B minus A, okay, this is our answer. Have a look at this beta. This is our answer. A intersection B is how much? A intersection B over here, closed bracket should be there. So this is not our answer. And A union B, if you see, it is minus infinity, say minus infinity say 2 union, closed 5 say infinity. So over here at 2 closed bracket should be there. Okay, so that's why this is not our answer. It's a very, very, very good problem. You should be able to solve these kind of problems since you have studied this topic for a very long time now. So the correct answer is B for Bombay. I hope you guys are clear with this particular thing. Also, I have attached some calculations for you people for your reference. You guys can check it out and can understand. Okay, a question which was asked in 2016, an equation f of x equal to twice of f of 1 by x where x is not equal to 0 is given to me. Okay, whenever you have been given such kind of an equation, let me tell you, whenever you are given such kind of an equation in which f of x and f of 1 by x is there, whenever you are given an equation in which f of x and f of 1 by x is there, you have to replace x by 1 by x. What I have told you, whenever you have got an equation in which f of x and f of 1 by x is there, you have to replace x by 1 by x and you have to write down one more equation. So if you replace x by 1 by x, over here you're going to get f of 1 by x. Over here it will become f of 1 by x, that will become ultimately f of x only. And over here it will become 3 by x. Yes, 3 by x. So let's call this as equation 2. It's a very, very, very important thing. I told you what? Whenever in an equation you have got f of x and f of 1 by x, replace x by 1 by x so that you get one more equation. Now with the help of these two equations, you have to eliminate f of 1 by x so that you can get the value of f of x, so that you can get f of x. This is a very, very, very important thing. Now our agenda is to eliminate f of 1 by x. So what do? Is we multiply this equation by 2 so that the coefficient of f of 1 by x becomes same. So in that case, over here it will become 4 and over here it will become 3 times 2, that is equal to 6 over x. Now subtract 1, do 1 minus 2. The moment you do 1 minus 2 bete, so over here you will be left out with f of x minus 4 times of f of x equal to 3x minus 6 by x. So that will be equal to how much? Minus 3 f of x is equal to 3 times of x minus 2 by x, means f of x is coming out to be 2 by x minus x. Yes or no beta ji? Do let me know. It's a very, 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 very important thing. Whenever f of x and f of 1 by x is given to us in a same problem, we need to replace x by 1 by x so that we can get one more equation, and then 1 minus 2 we can get the value of f of x by eliminating f of 1 by x. Alright. The question is saying what? The question is saying that S is a set such that f of x equal to f of minus x is getting satisfied. Now over here we have seen that f of x is nothing but 2 by x minus x. How do we get the value of f of minus x, kids? F of minus x can be written by simply replacing x by minus x in the following problem. So ultimately it is going to be this. So can we equate these two values? The moment we equate these two expressions, we're gonna get something like this beta. And this is 4 by x equal to 2x gives x square is equals to 2 gives x equal to plus root 2 or minus root 2 beta g. So our set S is having two elements in it, root 2 and minus root 2. I hope you guys are clear with this. Is this an empty set? The question is asking you. No sir. It is having two elements in it. Okay, contains exactly one element? No. Contains exactly two elements has to be the correct answer. Contains exactly more than two elements is also wrong. So we need to find out the set S in which f of x and f of minus x is always equal. So we have got the value of f of x. From there we have replaced x by minus x so that we can get the value of f of minus x. And we have solved for these two and we have solved for f of x equal to f of minus x. And ultimately we have got two values of x. So these are going to be the elements of the set S. and this is having exactly 2 elements in it. I hope you guys are clear with this. So the correct answer of the problem is coming out to be C for Calcutta. I hope you guys are having no difficulty at all. I have attached solution for your reference as well. If you want to do it on your own, you can have a look at this neatly. Okay, all right. I hope you remember this formula, as it is very, very, very important formula in permutations and combinations as well. Whenever you have done, let's say a number is divisible by 2 or 5, 2 or 5, or means union, so you might have used this particular formula over there as well. In probability also you're gonna follow this formula, so do remember this, as it is very, 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 very important bacha party. Okay, yes, so here is the proof attached. I hope you guys can see it. There has to be no issue at all, but let me tell you a few terms over here which are important for you to understand. This is set A, and let's say this is set B. Okay, yep, okay. If it is having x1 number of elements, x2 a number of elements, x3 number of elements, and x4 number of elements, x1, x2, x3, x4 are number of elements, number 1, number of elements. Okay, this is a very important thing. These are number of elements. If I ask you number of elements in only A means A minus B. If you remember, number of elements in A minus B, that they will be what? As per this diagram, they will be x1. Do remember this. Number 2, number of elements in A. So number of elements in A includes both this one as well as this one. Yes or no, beta? So they will be equal to x1 plus x2. If I ask you number of elements in B, they will be x2 plus x3. Number of elements in A complement means apart from A, x3 and x4. So the summation of these two. If I ask you number of elements in B complement, it will be equal to x1 plus x4. If I ask you number of elements in A intersection B, they will be x2. If I ask you number of elements in A union B, they will be x1 plus x2 plus x3. If I ask you number of elements in A union B is complement, so they will be what? They will be x4. Yes or no, everyone? I hope you guys are clear with these terminologies. Number of elements in only B will be what? x3. I hope you people understood these things. These are very, very, very important. Okay, one more. This is formula very, very, very important. When 3 sets are given, this formula is very important. Okay, over here also I would like to conclude a few things. This is the 8 regions Venn diagram. Yes or no, if you remember? Yes, this is set A. This is, let's say, set B, and let's say over here is set C. Okay, now let me write it down. x1, x2, x3, x4, x5, x6, x7 and x8. Here x1, x2, x3, x4 and so on are number of elements, number 1. Okay, if I ask you number of elements in set A, so they will be x2 plus x3 plus x5 plus x6. Yes or no? Similarly, if I ask you number of elements in B and C, in B it will be x3 plus x4 plus x6 plus x7. In C it will be x5 plus x6 plus x7 plus x8. I don't think there has to be any issue at all. Number of elements in A intersection B. What are the things common in A and B? That is x3 plus x6. Okay, this is a very important thing. If I ask you number of the elements which are common in B and C, they will be x6 plus x7. If I ask you number of the elements which are common in A and C, they will be x5 plus x6. Okay. Third one, number of the elements which are lying in A and B but not in C, A or B में lie कर रहे हैं but C में lie नहीं कर रहे, तो they will be x3. Have a look at this. Only these values. Because if you talk about A intersection B intersection C, so they will be x6. I hope you guys are clearly understood this one. Okay, number of the elements in only A will be nothing but x2 only. If I ask you number of the elements in only one of A, B and C, only one of A, B and C. So that is nothing but equal to x2 plus x4 plus x8, right? So do remember this, okay? Yes. If I ask you number of the elements in A union B union C, A union B union C, so that will be x2 plus x3 plus x4 plus x5 plus and so on till x8, yani ki except x1, okay? I hope you guys are clear with this particular thing. This is a very important takeaway from this particular slide. The proof is already attached. You guys can have a look at this. I have attached the proof, so for your reference you guys can definitely go through it and can make most out of it. Okay, let's do this problem. In a town 70% of the people are eating Indian food. Okay, I said let's say the total number of people who are eating Indian food is 70. I am taking 100 as the population. 50% people eat Chinese food. Okay, this is the case. Find the maximum and minimum percentage of people who eat both. Okay, if 70 people are eating Indian food and Chinese food is being eaten by 50 people, how many of the maximum number of people can eat both? 50 people can eat both, because 50 number of the people are eating Chinese, and that is a minimum value if we see in these two values. So at max there can be 50 people who can eat both, yes or no? Yes or no people. So the maximum value of the people who are eating both Indian and Chinese can be nothing but 50, yes or no? I said okay. If I need to find out minimum percentage of people who eat both Indian and Chinese, let's talk about that minimum. Okay, so you know this formula that A intersection B is equals to NA plus NB minus NA union C can be written. Okay, so number of the people eating Indian food, number of the people eating Chinese food, you know. Now you don't know about this. Okay, now let me tell you what can be if understand this thing. Very important thing. Now NI intersection C is nothing but equal to 120 minus NI union C. So this is, if I want this thing to be minimum, then this thing I am subtracting has to be maximum, yes or no? If I want this thing to be minimum, then I need to subtract the maximum value possible for I union C. Now what is the maximum value possible for I union C? Don't you think it is the entire population which can be the maximum one over here? So you can see that the minimum value of I intersection C will be nothing but 120 minus 100, that is equal to 20. So 20 people will be such that they are eating both Chinese and Indian, and at max 50 people can be there which eat both, and that is equal to 50. Okay, yes. So I hope you guys are clear with this particular problem. Talking about this, a class is having 175 number of students. The following data shows the number of the students opting one or more subjects. I said fine, okay. Mathematics 100 students, physics 70, chemistry 40, mathematics and physics 30, mathematics and chemistry 28, physics and chemistry 23, mathematics, physics and chemistry 18. Then find the total number of the students who opted only mathematics, and so on. Alright, so we need to draw a Venn diagram for the same. Okay, so this is how our Venn diagram will be looking like. 3 sets are there because 3 subjects are there. I said okay. Let's say this is for mathematics, this is for physics, and this is for chemistry. Okay, now always try to first write down this value. That means the people opting for physics, chemistry and mathematics, all 3 of them. Always try to write down this value first. Okay, yes. Yep. So the people who are opting for physics as well as mathematics as well as for chemistry are 18 in number. I said okay, this value is 18. Okay, now mathematics and physics are how much? Mathematics and physics are total 30. Now mathematics and physics written means this and this do combine to give you 30. So don't you think that this value will be 12? Okay, mathematics and chemistry in total are how much? 28. So this value and this value is nothing but 28 in total. So this value should be 10. Physics and chemistry in total are 23. So this value and this value should be in total 23. That means this should be 5. Okay, now this is mathematics total is 100. Mathematics the total is 100, so let me call this as x1. So x1 plus 12 plus 18 plus 10 should be equal to 100, isn't it? So can you tell me the value of x1 from here, people? 100 minus 40, so that is equal to 60, isn't it? I said fine, okay. Only physics, if I tell you that this is x2, only physics is x2. So x2 is equals to 100 minus 12 plus 18 plus 5, yes or no? So this is equal to how much? 100 minus 35. 100 minus 35 means this will be equal to nothing but 65. Okay, none of these three, I think you can definitely calculate it, because you can calculate the value of x3 quite comfortably. x3 is equal to how much? It will be equal to, okay, this was 70 only. I'm really sorry, because number of the students were in physics were only 70. Okay, so 70 over here, 70 minus this was 35, so this will be equal to 35 only. And over here total students in chemistry were 40, and if you subtract 10 plus 18 plus 5 from there, so how much you gonna get, beta? It is going to be 7 only. Yep. Okay, so only mathematics is nothing but x2. Only physics is, okay, sorry, it is x1. Only physics is x1, and none of these three is 175 minus the summation of all these. x1 that is 60, x2 that is 35, x3 that is 7 plus 12 plus 18 plus 10 plus 5. Subtract all these, you will get the value of none of the three. I hope you guys are clear with this. I have attached solution for your reference as well. You guys can definitely go through it and can understand if you are lacking somewhere in the problem. Okay. Alright, let's talk about this. We can do this through Venn diagram quite comfortably. If I'm taking this one as set A, this one as set B, then if you remember, I've told you this method, call it as region 1, call it as region 2, call it as region 3, call it as region 4. So A union B means region 2, region 3, region 4. So its complement is going to be region 1. So this entire thing is region 1 only, union. Okay, A complement is going to be what? Region 1 and region 4. And its intersection with region 3 and region 4 is going to be region 4 only. So region 1 and region 4 is coming in your Venn diagram. So that is going to be nothing but A complement only. So don't you think that your question can be solved in this way quite comfortably, kids? Yes, that's it. The problem is done. You can also solve by this method, method 2. You guys can follow it. I don't think there has to be any issue at all. So these are the problems I'm providing you as part of your practice of this Venn diagram in case you haven't done earlier. So this is set A, and over here will be, let's say, set B. So this is region 1, this is region 2, this is region 3, this is region 4. So A is going to be what? A is going to be region 2 plus region 3. B minus A is only B, that is region 4. So their union is region 2, region 3, region 4, and I think hence proved. Right? Because A union B is also region 2, region 3, region 4. There has to be no issue at all. Okay, so through shading also you guys can try by shading as well. Okay, try by shading as well, method 2. I hope you guys are clear with these problems. Anyone is having any issues? There has to be none. Okay, it is found that 21 people like product A, 21. Okay, so 3 sets are there. Let me draw diagram consisting 3 sets. First, 8 regions will be there. Yes or no, people? Okay, this is set A, this is set B, and somewhere over here will be set C. Let me bring it over here. Okay, 21 people are liking product A, 26 people are liking product B, 29 people are liking product C, 14 of the people are liking both A and B, 12 people are liking both C and A. Okay, if 8 is liking all 3, so over here first, A and B ko like karne wale were 14, so over here 6 will be there. C and A ko like karne wale were 12, C and O, okay, so this will be 4. B and C ko like karne wale were 14, so this will be 6. Now total people liking product A were 21, so this will be how much? This will be 3 people. Total people liking product 26 will be how much? 6. And total people liking product C were 29 in number, so 11. How many people like only one of the 3 product? Only one of the 3 product means 3 plus 6 plus 11. This one, this one and this one. Yes or no, people? So the answer is coming out to be what? 20. Yes, 20 is the correct answer. I hope you guys are clear with the problem. Yep. Okay, moving on to the next thing. B complement is going to be what? B complement is ultimately u minus b only. So from the universal set we need to remove the elements which are also coming in B. So 1, 3, 4, 5, 6, 8 will remain. If you do A complement, it is going to be u minus a, remove the elements from the universal set which are also coming in A. That means 4, 6, 7, 8, 9 and 10 will remain. If you do B complement minus A complement, so over here if you see, do we need to remove 1? No sir. Do we need to remove 3? No sir. Do we need to remove 4? Yes sir. Do we need to remove 6? Yes sir. Do we need to remove 8? Yes sir. So we are left out with what? We are left out with this particular thing is coming out to be 1, 3, 5. A minus B is how much? A minus B. A minus B. Talking about A minus B, do we need to remove this? No. Do we need to remove this? Yes. Do we need to remove this? No. Do we need to remove? Yes. Both equal, hence proved. Yes, I hope you guys are clear with this. You guys can refer this particular diagram and I think there has to be no issue at all. There has to be no issue at all. Okay, talking about this. If x is equal to n where n is a natural number, so A set can be written like this: 1, 2, 3, 4, 5 and so on. Natural number is never ending. Okay. B set can be written as 2 into n where n is a natural number, so B set can be written as 2, 4, 6, 8, 10, 12 and so on. Yes or no, everyone? Okay. C set is 4n, so it can be written as 4, 8, 12, 16, 20, 24 and so on. Okay. The question is asking you first B union C can be written. B union C will be what? B union C. B union C will be 2, 4, 6, 8 and so on only. That is B only. Yes or no? And A intersection B, because you guys can see one thing over here, that B, C, let me tell you this. This relation is being followed in the problem. Can you observe this? This relation is being followed in the problem. So A intersection B has to be equal to B only. A intersection B has to be equal to B only. So the answer has to be equal to B only. Okay, yes, and that's it. The question is done. Over here, you guys can see the solution. There has to be no issue at all, and you have to pick this much speed now because you have already covered class 11th. Okay, yes, talking about this. You can do this in multiple ways. This is set A, let's say, this is set B. Okay, if I want to write down B minus A will be this. And what is the common between these two? I don't think that there is anything in common. Set A is this. These two regions have nothing in common, so hence proved. Yes or no, people? Have a look at this. I hope you guys are clear with this problem. Okay, now we are done with sets. It's time to form relations, and then we're going to talk about functions, kids. So it's very important that we first master relations and then move towards functions. Let me tell you one very important thing. Then in real life we do have relations, in real life we do have functions. So we're going to take the same analogy to understand these concepts. But before that, we need to understand Cartesian product. Cartesian product. So let's first understand that, because Cartesian product is very important. If we understand Cartesian product, then only we will be able to understand relations, and then we will be able to understand functions. So in order to understand Cartesian product, let me tell you to a journey. Saif weds Karina, and let's understand this this analogy, through this analogy, Cartesian product. Okay, yes. Now in India, I hope you people know that if a marriage is being conducted between two people, then it is not just an affair of these two people but also of the entire family. Yes or no? Yes. So let's say Saif and Karina are getting married. So we need to bring Saif's family as well as Karina's family, because the new connections will be forming in both of the families because of this marriage. Yes or no? So if we are doing Saif weds Karina, then because of this marriage, what will happen? Because of this marriage, Saif is going to form a new connection with Karina. Saif is going to form a new connection with Karishma. Saif is going to form a new connection with Ranbir as well. Yes or no? Similarly, because of this marriage, Saif's sister, that is Soha, is also going to form a new connection with Karina, new connection with Karishma, and a new connection with Ranbir. Yes or no, everyone? So how many new connections will be formed because of this marriage, Saif weds Karina? I think you can count this down. These are 6 connections. Yes or no? Okay. So Saif will be forming connection with each and every member of Karina's family. And similarly, this Soha will also be forming connection with each and every other family member of Karina. Yes or no? So we guys have noticed one thing over here. Each member of Saif's family, each member of Saif's family is forming a new connection, with every member of Karina's family. Yes or no? Because of this marriage, yes or no? Every member of Karina's family. Yes or no, everyone? Each member of Saif's family is going to form a new connection with each and every member of Karina's family. So we can see that these are the 6 new connections forming. Saif forming a connection with Karina, Saif forming connection with Karishma, Saif forming a connection with Ranbir, Soha forming a connection with Karishma, Soha with Karishma, and Soha with Ranbir. These were the 6 new connections observed. Right. So over here you can notice one thing, that each member of Saif's family is forming a new connection with every member of Karina's family. And also in these connections, if you see, Saif's family member is written first. Saif's family member is written first always. Look, Saif first, then over here Soha, and Soha first. Why is this? It is because we were talking about Saif weds Karina. If we will talk about Karina weds Saif, then we will say that every member of Karina's family is going to form new connection with Saif as well. So basically in mathematics, we will be considering Saif weds Karina and Karina weds Saif as 2 different things. So if we talk about Karina weds Saif, then over here in the Karina's family, 3 members were there: Karina, Karishma, and Ranbir. And in the Saif's family, we were having 2 family members, Saif and Soha. So because of this marriage, can you guys feel that this will be one new connection formed, this will be another new connection formed? Similarly, Karishma with Saif, Karishma with Soha. Similarly, Ranbir with Saif, Ranbir with Soha. So these will be the 6 connections. Over here, you guys can see, since this is a member of Karina weds Saif, so Karina's family members are written first. As I told you, Karina weds Saif and Saif weds Karina will be considered as different things in mathematics, because whosoever is conducting the reception, their name will be written first. So this is the reception of Karina's family, reception being organized by Karina's family, and this reception is being organized by Saif's family. So over here, expenses will be beared by Saif's family, and over there, the expenses will be beared by Karina's family. That's why I have written Karina's family member's name first. Yes or no? So since mathematics is also very much about calculations and a marriage is also very much about calculations because a lot of money is involved. So Saif weds Karina and Karina weds Saif will be considered as 2 different things. Over here, if we write down the connections, Saif's family members will be written first, and over here, if we write down the connections, Karina's family members will be written first. Yes or no? So this connection is going to be a part of Saif weds Karina. Yes or no? And this connection will be a part of Karina weds Saif. Yes, this is nothing but the foundation of ordered pairs. In mathematics also, there will be ordered pairs, A comma B and B comma A. So these 2 will be considered as different. Okay. Yes, so that is the foundation of ordered pair. Alright. Now if you have understood this analogy, then let me take you to Cartesian product now. If let's say Saif is nothing but small a and Soha is nothing but small b, Karina is 1, Karishma is 2, Ranbir is 3, then if and let's say this is set A and this is set B. If I'm talking about Karina weds Saif weds Karina, Saif weds Karina, then I can assume it as A cross B, because A is Saif's family and B is Karina's family. So A cross B means marriage is going on between 2 families. Yes, this A will be connected with 1 new connection, A will be connected with 2, A will be connected with 3 as well. Not just this, but B will be connected with 1, B will be connected with 2, B will be connected with 3. So these will be the connections formed. Yes or no? So let me show it to you guys that your A cross B will be consisting of all these new connections in that case. Yes or no, everyone? If we talk about, obviously a comma 1 and 1 comma a will be different, as I told you, just like Saf and getting connected with Karina and Karina getting connected with Saf were two different things. So that was the foundation of ordered pair. Okay, and if you are talking about Saf weds Karina, so these are going to be the ordered pairs. So A cross B, as we have just seen will be looking like this. And if we talk about Karina weds Saf, then you guys can imagine that over here 1, 2, 3, over here A, B was written. So 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A, 3 comma B will come. So this is nothing but Karina weds Saf. Yes. And as I told you, 1 comma and a comma 1 will be considered different as this is an ordered pair, right? So Cartesian product, if we define it formally, the Cartesian product of two sets A and B is nothing but set of all the possible ordered pairs A comma B which are possible, such that the first thing is written from this first set A and the second thing is written from the second set B. Okay. Small a belongs to the capital set A and the small b belongs to the capital B set. Okay, so A cross B is consisting of all those ordered pairs small a comma small b, where the first thing is coming from this set and the second thing is coming from this set. Okay, yes, that is the formal definition of Cartesian product. Alright, let's talk about this. This is nothing but, now A cross B is also a set. A cross B is also a set. Okay, I have told you one thing, that A cross B and B cross A were different things. So let me write it down over here. A cross B and B cross A are different things. Okay. Yes. Let's talk about this. If A set is given to me like this 1 comma 3 comma 4 and B set is given to me like this 7 comma 10 comma 12, then if we talk about A cross B, our A cross B will be looking something like this: 1 comma 7, 1 comma 10, 1 comma 12. Not just this, but 3 comma 7, 3 comma 10, 3 comma 12, 4 comma 7, 4 comma 10, 4 comma 12. Yes or no, everyone? How many elements or ordered pairs are written inside? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is asking me number of the elements in A cross B, so that will be nothing but equal to 9. Let me tell you one very important formula over here. Number of the elements in A cross B is always equal to number of elements in A times number of elements in B. And also let me tell you one thing, that number of the elements in B cross A are also same, though B cross A and A cross B are different sets, but still their cardinality is same. A cross B and B cross A do have same cardinality, though they are different sets. I hope you guys are clear with this, as you guys can apply over here as well this formula. Over here, if you see, the cardinality of the set A is nothing but 3. The cardinality of set B is also equal to 3. That's why the number of the elements in A cross B has to be equal to what? Na into Nb, that is equal to 3 into 3, that is equal to nothing but 9 only. I hope you guys are clear with this particular problem. Ordered pair, order is there. So A comma B will be different from B comma A until B and A are equal, right? If A and B are equal, then obviously the A comma B will be same as B comma A. Okay, if A is this set given to me and B is this set given to me, can you write down A cross B like this? Have a look at this. A cross B, the connections will be formed like this. And if we talk about B cross A, the connections will be formed in this fashion. Yes or no? So they will be different, isn't it? As I told you, 1 comma L is going to be different from L comma 1 and so on. But their cardinality will remain same. And that will be how much? Number of the elements in A cross B is equal to number of elements in B cross A is equal to number of elements in A times number of elements in B. I hope you guys are clear with this particular thing. Yep. Okay. A cross B and B cross A are different things, though their cardinality is same. Okay. Let's do this problem up. Come on, kids. A is a set given to me satisfying that particular equation. So A set will be having 2 elements, 2 and 3, yes or no? Okay. B is having 3 elements in it, 2, 4 and 6. And C is having elements 4 and 5. The question is asking A cross B intersection C is going to be what? So can you first write down B intersection C, kids? The things which are common in B and C, that is nothing but 4. So ultimately what you have to write down is A set over here. Let me write it down. A set is 2 comma 3 and B intersection C is 4. So can you perform this marriage. People over here, 2 people are there, 2 and 3, over here 4 is there. So ultimately what is going to happen, that this 2 is going to form a connection with 4 and this 3 is also going to form a connection with 4. So ultimately your this set is going to be like this or not. Everyone do let me know any issues in this problem. Feel free to reach out to me. Not an issue? Okay. Cardinality we have already seen. If set A is having 3 elements in it, then the cardinality of the set A is going to be nothing but equal to 3 only. Subset also we have seen, right? Over here, if B set is equal to 1, 2, 3, 5, and if set A is equal to 1, 2, 3, so whatever this A is having, it is also there in B. So we say that A is a subset of B, or we can say B is a superset of A. I hope you have already understood this concept. So over here we can say that A is a subset of C. A is a subset of C, sorry. A is a subset of C. Okay, and B. This entire green set is B. A is a subset of B over here, and C is not a subset of B. Okay, and A is also not a subset of C. Okay, yes, if A set is given to you like this, B set is given to you like this, C set is given to you like this, can you say that A is a proper subset of A? Okay, proper subset means all the subsets except the equal set are known as proper subsets. Okay, and C is not a subset of B, as you guys can visually see over here. Okay, subsets definition we have already seen this, so we are quickly going to move ahead. If a set is having n elements in it, then the number of the subsets of n A can be written as 2 to the power n. Okay, yep. Can you do this A cross A? Sir, this can also happen. Yes, forever alone. The people who will always remain single, for them this marriage we are going to conduct. So this connection, this connection, this connection, not only this, the same connections will be formed by 2 as well. So 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Yes or no? I hope you guys are clear with this particular thing. And if you check the cardinality of this set, so NA cross A will be equal to what? NA into NA. So that will be equal to nothing but 3 into 3. Yes or no? So that is equal to 9. Look, 9 number of elements are written in A cross A. Yes, I hope you guys are clear with this particular thing. A very good problem. Very good problem. I am giving you guys, you have to solve this problem. Come on, think over it. Just try to pause the video and try to solve this question on your own, people. Come on. Can we first write down S1 cross S2, people, because S1 cross S2 has been used somewhere in the problem. S1 cross S2. S1 is the set given to you, S2 is that set given to you. So 1 comma A, 1 comma B, 1 comma C and 1 comma D. I said fine, okay. Then 2 comma A, 2 comma B, 2 comma C, 2 comma D. Yes or no? And like this, 3 comma A, 3 comma B, 3 comma C, 3 comma D. I said okay. Moving like this, 20 comma A, 20 comma B, 20 comma C, 20 comma D. Yes or no, beta? So this is our S1 cross S2. Yes. Okay. Talking about S1 cross S3, people. S1 cross S3 will be how much? It will be 1 comma B, 1 comma D, 1 comma E, 1 comma F. Okay. 2 comma B, 2 comma D, 2 comma E, 2 comma F. 3 comma B, 3 comma D, 3 comma E, 3 comma F. Yes or no, people? And so on till 20 comma B, 20 comma D, 20 comma E, 20 comma F. Yes or no? Okay. Now the question is asking you what? The question is asking you number of the elements in this union this. Okay. Can I call it as A? Can I call it as B? So S1 cross S2 I am calling it as A. S1 cross S3 I am calling it as B. So the question is like this: NA union B. I hope you know the formula. NA plus NB minus NA intersection B. Yes or no? Okay, I said. Number of the elements in S1 cross S2, I think you can write down 20 into 4, 80. Number of the elements in S1 cross S3, I hope you guys can write down 20 into 4, that is 80. Okay, how many elements are common in these two is what we need to count down. Okay, let's count down the common elements. 1 comma a and 1 comma b are common. Then 2 comma a and 2 comma b will be common. 3 comma a and 3 comma b will be common. Like this, if you move on, how many elements are common in these two? How many elements are common in these two? I think 40 elements are common, yes or no? So what is the answer coming? 120? So the answer of this question is 120B for Bombay. It's a very good question because it gives you a conceptual clarity at a very good level, right? Okay, let's talk about this question. If A is a set in which x belonging to R is given and x is going from 0 to 1, okay, and B is going from -1 to 1, A cross B is the set of all points. Okay, if I'm talking about A cross B, then I'll mark it as A comma B such that A is coming from A and B is coming from B, isn't it? If I assume this as x comma y, understand this everyone, it's a very beautiful question. If I assume this point as x comma y, then x has to be from set A and y has to be from set B, yes or no everyone? Okay, so I can see over here that if I need to plot A cross B will be consisting of all points x comma y such that x is from set A and y is from set B. Okay, if x is between 0 to 1, so how many values are there? Infinite values. And these are also infinite values, isn't it? Because these are real numbers given to me. So I said, because between any two real numbers there lies infinite real numbers. I hope you guys are aware of this. Okay, so ultimately my x is going from where to where? My x is going from 0 to 1. And my y is going from where to where? It is going from -1 to 1. I hope you guys know now that x equal to constant is a vertical line. So this is going to be x equal to 0, yes or no? And this is going to be x equal to 1, yes or no, bacha party, do let me know. Okay, talking about this, y is going from -1 to 1 means y is going, this is y equal to 1 and over here somewhere will be y equal to -1. So don't you think that A cross B will be consisting of all these points lying inside this particular thing? Over here this point will be what? This point will be 1 comma 1, this one is going to be 0 comma 1, this one is going to be 0 comma -1, this one is going to be 1 comma -1, yes or no people? So is this a rectangle or a square? I think this is a square, rectangle, yes. Okay, so inside this region, any point inside this region, don't you think will be lying in A cross B? Because A cross B is consisting of x comma y, where x is any point from the set A and y is any point from the set B. So inside the rectangle, not on the boundary, because over here x cannot be equal to 0 and 1 and over here y cannot be equal to -1 and 1. So inside the rectangle has to be our answer, on the sides is never be our answer, is going to be our answer. So inside the rectangle, and the rectangle is forming at 1 1 0 1 0 -1 and 1 -1. So I think this is going to be our answer. Yes, I hope you people are clear with this particular question. It's a very beautiful question. Okay, talking about relations now. The moment we just had marriage between Saif and Kareena, so if these people have got married, so relations are going to form, isn't it? Relations are going to form. So now we are going to study relations because we have already learned Cartesian product. So now let's go and understand relations. All right, here we go people. Relations. Now let's understand the definition of the term relation. A and B, if A and B are any two non-empty sets, then a relation R from A to B is nothing but a subset of A cross B. A very important definition. Any subset of A cross B is a relation from A to B. Any subset of A cross B is a relation from set A to B. Yes, any subset of A cross B is the relation from A to B. Now let's understand this particular thing over here. Let's say set A, you have been given three elements, A1, A2, A3, and in set B you have been given these four elements, B1, B2, B3, B4. Can you write it down A cross B, guys? Yes, A1 comma B1, A1 comma B2, A1 comma B3, A1 comma B4, A2 comma B1, A2 comma B2, A2 comma B3, A2 comma B4, A3 comma B1, A3 comma B2, A3 comma B3, A3 comma B4. Yes or no? So if I talk about the cardinality of the set A cross B, it is going to be number of elements in A times number of elements in B, that is equal to 3 times 4. Yes or no? That is equal to 12. Okay. Now, if I give you a relation R like this, okay. Now, is this R a subset of A cross B? Is this R a subset of A cross B? Is this R a subset of A cross B? Do let me know. Yes or no, everyone. Is this R a subset of A cross B? No. Yes, I think it is. Because A1 comma B2 will definitely come here. A3 comma B1 will also come in A cross B. Yes or no? Yes, sir. So yes, R is nothing but a subset of A cross B, and I have told you a very important definition. Any subset of A cross B is a relation from A to B. So can we say that this R is a relation from A to B? Okay, if this is a set, then A1 is getting connected with B2, yes or no? So I can show it like this in mapping. A3 is connected with B1, A3 is connected with B1, I can show it like this. So this relation R in terms of connections can also be represented like this. Yes. So any subset of A cross B is the relation from set A to B. So this R is a subset of A cross B. That's why we say that this is a relation from A to B. So what exactly is a subset? A subset. What exactly is a relation? A relation is nothing but any subset of A cross B. A relation is nothing but any subset of A cross B. Okay. Now, A cross B ki cardinality is nothing but Na times Nb. Number of elements in A times number of element in B. Okay. So, if I ask you what will be the number of subsets of A cross B? Number of subsets of A cross B. Number of subsets of A cross B. Sir, A cross B is also a set, and if I want to write down number of subsets of any particular set, then we write down 2 to the power number of elements in it. So 2 to the power number of elements in it is going to be nothing but 2 to the power Na times Nb. Yes or no? Anyone is having any confusion in this? Do let me know. And if I am asking you what will be the number of relations from A to B, then I have just told you that number of relations from A to B is nothing but number of subsets from A to B only. So I can say that this many number of relations from A to B can also be written. If I ask you number of relations from A to B are how much, then they are nothing but 2 to the power number of elements in A times number of elements in B, because number of relations from A to B is nothing but equal to number of subsets from A to B, because number of subsets of A cross B, because any subset of A cross B is the relation from A to B. Any subset of A cross B is the relation from A to B. Okay. Now, let's say if a set A is given to me like this, can I first find out A cross A, people? Can I first find out A cross A? Yes, sir. A1, 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 A2, A1, A3, A1, A4, A2, A1, A2, 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 A3, A3, A2, A4, A3, A1, A3, A2, A3, 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 A4, A4, A1, A4, A2, A4, A3, A4, A4. Yes or no? So A cross A will be having how many elements in it? It will be having Na into Na, that is equal to 4 times 4, that is equal to 16 elements. Yes or no? So if I ask you number of subsets of A cross A, so that will be equal to 2 to the power 16, and that many relations from A to A can be written. Yes or no? Number of relations from A to A will be how much? It will be equal to 2 to the power 16. Okay, this thing in short can also be written as number of relations on A. Number of relations on A. I don't wanted to write down this thing from A to A again and again. From A to A. Since these are same only, so in short I can write it as on A as well. Okay, so that will be nothing but 2 to the power 16. Okay, so if let's say this is R, this R set is given to me like this, and the question is asking me, is this R a subset of A cross A? So A1, A2 will definitely come in A cross A, yes or no? A2 comma A3 will also come, A2 comma A4 will also come. So this R is nothing but a subset of A cross A, hence we can also call it as relation on the set A. I hope you guys are clear with this. And like this, 2 to the power 16, imagine this number, that many relations from A to A can be written if set A is given to you like this, A1 comma A2 comma A3 comma A4. Imagine the number of relations you guys can write down. I hope this is clear to all of you guys. If set A is given to me as even natural numbers less than 8, even natural numbers less than 8 will be 2, 4 and 6. And B is the set of prime numbers less than 7, prime numbers less than 7, so 2, 3, 5. Then the number of relations from A to B. So first you guys can write down the number of elements in set A cross B. So that will be equal to number of elements in A times number of elements in B, that is equal to 3 times 3, that is equal to 9. Okay. Now any subset of A cross B, any subset of A cross B is a relation from A to B, yes or no? Yes sir, it's a relation from A to B. So I told you one thing, number of subsets of A cross B will be equal to number of relations from A to B. So if the question is asking you number of relations from A to B, that means you need to just write down the number of the subsets of this particular set. So it will be equal to 2 to the power 9. Yes or no? I hope the question is clear to all of you guys. Okay. We'll talk about this, but a bit later. Let me tell you this. Okay. Let me tell you this here only. We're going to talk about domain, range and these technical terms through this example. Okay. Yes. Relation on N. Look, relation on N means relation from N to N. Relation on N means what? On N means relation from N to N. Relation from N to N. Yes or no? N is nothing but set of natural numbers. And this N is nothing but set of natural numbers. I said fine. Okay. Now over here this relation R is given to me like this, x comma y, such that x plus 2y is equal to 8. I said okay, and x and y obviously has to be natural numbers only because these two values has to be from N to N. So x is also coming from natural numbers, y is also coming from natural numbers. I said okay. So you guys can see the least natural number x is 1, then 2, then 3, then 4, then 5, then 6. These values are possible. So let me write it down. Whenever I am taking these values of x, what are the values of y I am getting? Let's find out. The value of y following this relation will be 7 by 2. Okay, the value of y following that relation, if x is equal to 2 is there, so it is going to be 3. Over here y equal to 5 by 2. Over here y will be equal to 2. Over here y will be equal to 3 by 2. Over here y will be equal to 1. Over here y will be equal to 1 by 2, and over here y will be equal to 0. And then if you take x equal to 9, the y will be equal to minus 1 by 2 and so on. But over here understand one thing. X and y needed to be natural numbers only. Don't you think that here x and y are both not natural numbers, here also x and y are not both natural numbers, here also x and y are both not natural numbers, here also x and y are not both natural numbers, here also x and y are both not natural numbers, here also x and y are not both natural numbers, yes or no? And so on if you move, and so on if you move, and so on if you move. No value of y will be natural number, yes or no? Natural number, yes sir. So therefore no other value of that x and y both being natural number is possible. So our relation R will be consisting of only those ordered pairs in which x and y are both natural numbers. So that is 2 comma 3, this one 4 comma 2, this one 6 comma 1. That's it. So our relation R will be looking something like this only. Understood? Okay. Now if this is our relation R, then what is the domain of the relation R? Domain of R. Domain of R is nothing but the values which are coming first in these ordered pairs. Domain is nothing but the values which are coming first in the ordered pair. So what is the domain? 2, 4 and 6. Okay, what is the range? Range is the values which are coming later in the ordered pair. Range is what? Range are the values which are coming later in the ordered pair. So what is there in the range? The range is consisting of 3, 2 and 1. I hope you guys are clear with this. And what is codomain? Codomain is, this relation was from n to n. So this is your codomain always. This entire set is your codomain. So what is a domain in a relation? The domain in a relation is whatever values which are written first in the ordered pair. So 2, 4, 6 is there in the domain. What is range? The things which are written later in the ordered pairs is always your range. And what is codomain? If a relation is from A to B, then B is the codomain of that particular relation. I hope you guys are clear with these three technical terms. Yes, everyone? I hope you guys are clear with these three technical terms. Alright, so you have to write down the answer of this particular problem below the video. Homework 1. Write down the question is asking you false statement. Okay, the question is asking you false statement. Be careful about this. Be careful. You have to write down the answer in the comment section below the video. Answer below in comment section, kids, in comment section. Okay, all right, moving on to the next problem. If A and B are given to me like this, A and B, then the number of the relations from A to B is equal to, from A to B is equal to number of subsets of A cross B, number of subsets of A cross B, and number of subsets of A cross B is nothing but number of elements in this. So that will be equal to 2 to the power 3 into 2, that is equal to 2 to the power 6, right? I hope you guys are clear with this. Okay, it is asking you empty relations, non-empty. So one relation is always going to be empty because one subset is always empty, yes or no? So ultimately you have to remove that. So the answer of this is going to be total number of subsets minus one subset, which is going to be empty. So ultimately total number of relations minus one empty relation. So the answer is going to be D for Delhi. I hope you guys are clear with this. This is the homework number 2 that you have to do. You have to write down the answer in the comment section below the video. Answer in comment section below the video. Okay, kids. I hope you can do this quite easily. There has to be no issue at all. This is homework 3. You have to write down the answer in the comment section. Answer below. Okay. Yep. Okay, this is question number 4, homework number 4. You have to answer it below the comment sections. Okay, relations. As I just told you that any subset of A cross B is nothing but a relation from A to B. So a relation is consisting of those ordered pairs such that X belongs to set A, Y belongs to set B, and X is related to Y. Let's say A is given to me like this, B is given to me like this. A cross B I can find out, and if I take any R like this, let's say 1, 8. Is this a subset of A cross B? Yes sir, this R is a subset of A cross B, hence R is a relation from A to B. From A to B, and what is the domain of the relation R? 1. What is range of the relation R? 8. Okay, and how many relations from A to B can be written? 2 to the power number of elements in A cross B, that is equal to 2 to the power 9. I hope you guys are clear with what we have learnt so far. Yep. Okay, now if a relation R is given to me like this, then I can say that 1, 1 can also be represented by 1R1, 2, 8 ordered pair can also be represented by 2R8, 3, 27 ordered pair can also be written as 3R8. I hope you understood this. Also, if you see over here, you will say that 27 is the image of 3. You can also say that 8 is the image of 2, like this. And you can also say here that 3 is pre-image of 27. You can say from here that 2 is pre-image of 8. Okay. Yes, that's it. Okay, this question, homework number 5, I think now you can do it quite easily. There has to be no issue at all. And then domain of a relation, as I have told you, every ordered pairs, first things before the commas is your domain. Every ordered pairs, later things are going to be your domain, range of the relation. and range domain of the R in this relation is going to be 1, 2 because repetition is not done in the set, and range is going to be x, z, and the codomain, since it is a relation from A to B, so the codomain is going to be B set, right? I hope you guys are clear with these technical terms. Okay, so this is homework number 6 that I am assigning to you people. I hope you can solve it without any issues. Okay, this is homework number 7. Okay. Yep, number of relations, as you have seen the formula, 2 to the power number of elements in A cross B. Okay, let's talk about R inverse. Now it is quite easy. If R is given to me like this, then what is the meaning of R inverse? You have to just flip the every ordered pair. So 2, 4 is there in the R inverse, it will be 4, 2. 3, 9 is there, it will be 9, 3 in the R inverse. 4, 16 is there, it will be 16, 4 in the R inverse, right? Yes. So I hope you guys are clear with this. Okay, here domain of R inverse is what you need to find out. This is a very good question. I'm giving you this question as part of homework. You have to tell me the answer below in the comment section, people. Okay, yes, and this question is very important. I'm giving you, I will discuss this question in the next, we'll discuss this in next class, because we will be covering this sets, relations and functions in 2 portions. So this was part 1 for today, and we will take part 2 in the next session. So in the next session we will be starting functions, but before that we will take the question that we have just seen on the previous page. Do not forget to attempt this question, as it is a very important and a very good problem. Okay, so from here we're gonna take in the next class. Stay tuned, keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much. Bye bye, take care. Okay, now let's talk about functions. So first we're gonna cover here function as a special type of relation. Then we're gonna have a look at graph of a function and different types of functions is what we're gonna study in this. So in order to understand functions, let's take a gaming battle, and it will be easier to understand functions this way. Let's say there are 2 armies, our army and opposition's army, the 2 armies fighting. Okay, I hope you people have played the game of PUBG, right? So in this game, if these 2 rules are followed, then we can say a relation is a function. Relation is nothing but a game. Okay, yes. Okay, number 1 rule is 1 person 1 bullet. That means members of our army will be shooting. Members of our army will be shooting. Number 1, who will be shooting? Only our army. You can feel as if the opposition army is like Pakistan's army. Their economic situation is not that good. 1 person 1 bullet, and everyone has to shoot. Everyone has to shoot means from our family, from our army, everyone from our army has to shoot, and that too 1 person 1 bullet. Okay, if these 2 conditions are getting satisfied, then we say that a game or a relation is going to be a function. Okay, let's go. Here we go. If this is our army and this is opposition's army, what I told you, this is only our army will be shooting, 1 person 1 bullet, and everyone has to shoot. If these 2 conditions are there, then we're gonna say that that game or that relation is going to be a function. So let's take about this relation 1 or game 1. Every member of our army is shooting. Look at the arrow. The arrow is pointing towards this. That means our members are shooting. Yes. 1 person 1 bullet or not. Every person is shooting, and that too 1 bullet only. Yes. So that's why this game is nothing but a function. Right? Okay. Both the conditions are getting satisfied. Here also, every member of our army is shooting, and that too one bullet. So this is also a function. Okay. Talking about this, every member of our army is shooting, and that too one bullet only. So this is also a function. Over here, this guy is not shooting, not shooting. If this game or this relation is a function, then everyone from our army has to shoot, and that too one bullet. So this is not a function. Yes? Okay, moving ahead. Talking about this, everyone is shooting, but this guy is shooting 2 bullets. So is this going to be a function? No, not a function, because everyone has to shoot only 1 bullet only. Yes or no? So this guy is acting as if he's Rajnikant sir, right? I have given him 2 bullets and he's shooting 2. And you people know we cannot invite Rajnikant sir to our functions because he is having a huge fan base, and we will not be able to do the security work. So that's why we can relate as if we can't allow Rajnikant sir in our function. Okay, a relation will be called a function if these 2 conditions are satisfied. Okay, now let me give you this example in mathematical terms. All right, let's say this is A, this is B, this is C, this is 1, 2 and 3. Over here, this relation R can also be written like this: A comma 1, B comma 2, C comma 3. Now you can feel that if you do, let's say this is our army A and this is the opposition's army B. I hope you people can write down A cross B quite comfortably. So A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma 3, C comma 1, C comma 2, C comma 3. 9 elements are there, so 2 to the power 9 number of subsets of A cross B can be written. So that many relations from A to B can be written. Out of those relations, one relation is given to me like this, or in mapping if I see the very same relation can be represented like this. Now, is this relation a function? So if this relation is a function, then every member of our army has to shoot, and that to 1 bullet only. So this is going to be a function. So this relation is also a function. This relation is also a function. This relation is also a function. I hope you people understood the concept. Yes. Okay. Talking about this will also be a function. If this is A, this is B, this is C, this is 1, this is 2, this is 3. So this relation can be written like this: A comma 1, B comma 1, C comma 3. Now look, both of these guys are killing this guy, that is fine. But one person, 1 bullet, and everyone has to shoot. These were the 2 conditions. So that's why this relation is also a function. Okay, provided that our army is this and opposition's army is this. Yes, I hope you people understood the game. I hope you people can easily identify relations now. So if the relation R is given to me like this: A comma 1, B comma 1, C comma 1, is this going to be a function? Yes, this is going to be a function. Okay, so I hope you people understood when a relation will be called a function. So let's have the formal definition over here. A relation which is going from A to B is considered a function if every element in A has a mapping. That means everyone is shooting from our army, and every element in A has a unique mapping, has single mapping. It should be single mapping, has a single mapping, not unique mapping, it has to be single mapping. Okay. Yep. So 1 person, 1 bullet, and everyone has to shoot. These were the 2 conditions. Mapping means those arrows. Okay. Set A is nothing but domain. Our army is known as what? Domain. Our army. And the entire opposition's army is not range. That is known as codomain. Opposition's army. So if a relation is going from A to B, and if it is a function, then A is called as domain and B is called as codomain. Okay. Alright, is this relation R a function? Yes, because everyone is shooting from our army, and that to 1 bullet only. Look, 1, 2, F1, 2 and 3 all are shooting, and that to 1 bullet only. Is this going to be a function? Look, 1 and 2 both are shooting, and that to 1 bullet only. So this is also a function. Talking about this, is this a function? Is this relation a function? Yes, because every member from our army is shooting, and that to 1 bullet only. Is this relation a function? No, not a function. Why? Because 4 is not shooting. Yes or no, everyone? Okay, is this relation going to be a function? No, not a function, because 4 is not shooting and also 1 is shooting 2 bullets. Yes or no, everyone? Alright, let's try to see how to identify whether the given graph is of a function or not. Okay, so you can say that graph we can form for relations. Graph we can form for relations, like as if I ask you y square equal to x. Okay, now I hope that you people have gone through parabola chapter. So there you might have observed that the graph is drawn like this. Now this is nothing but the values of x, this is nothing but the values of y. Okay, yes, now try to understand this. X means it is domain and y means it is range. Let me introduce the term range as well for you before I go into this. Okay, so if this is our function, then A is nothing but domain. So domain is what over here 1, 2 and 3. Okay, B is nothing but codomain, that is x and x and y. And if you look over here, range, the range is what? Who have been shot in the opposition army. So this man is also killing x, this man is also killing x, this man is also killing x. So range consisted of only element x in this particular thing. Range is somebody who is under my range, whosoever coming under my radar and has been shot. Yes or no? So who has been shot is coming under my range. That has to be an element of codomain only. Yes or no, everyone? Okay. Over here, if you see, is the range going to be equal to codomain over here? All people have been shot. That means entire opposition army is dead. So we say that range is equals to codomain. Yes. Here, if you see range is going to be W and X only. Whereas if you talk about codomain is the entire opposition army. So that is W, X, Y and Z. I hope you people are clear with this. Over here they are both equal and they are X, Y and Z. Yes? Okay. I hope you people understood these technical terms. Okay. Now look. This Y is nothing but range. Okay. X is what? Domain and Y is what? Range. Now look. If you look for this particular X, can you see that you have got two values of Y? One over here and one over here. Yes or no? So one value of X gives two values of Y. That means one person is killing two people. So is this going to be a function? One person from our army is killing two people from opposition army. So can one guy shot two bullets? No, sir. So is this relation going to be a function? This relation is not a function. This relation is not a function. Yes or no? Why is this not a function? This is not a function because one person, that is for this value of X, we are getting two values of Y. That means one person from our army is shooting two people from the opposition army. So that cannot happen in a function because one person, one bullet was the rule. So exactly what we have done over here is vertical line test. What is this vertical line test? This vertical line test is used to identify whether the graph is of a function or not. Whether the graph is of a function or not, or whether the given relation is a function or not in graphical terms. Even if you get a single vertical line which cuts the graph at two or more than 2 points, then it is not a function. Understand? Single vertical line. On a vertical line, X remains constant. Even for a single X, if you get two or more than two values of Y, that means one member of your army is shooting two or more than two bullets. That cannot happen in a function. So let's say if a graph is given to me like this, will you ever get even a single vertical line which cuts this graph at 2 or more than 2 points? No sir. So that's why this is a function. Over here, if you see, is this going to be a function? Even if you get a single vertical line which is cutting the graph at 2 or more than 2 points, then it is not a function. So this graph is not a function. Ellipse, is ellipse a function? No sir, because if you do a vertical line like this, it will be cutting the graph at 2 or more than 2 points, so it is not going to be a function. Okay, how do we draw graphs initially? I hope you people know that the graph for y square is equals to x will be coming out to be like this. Over here it is going to be 0, 0. Over here it is going to be 2, 4, 1, 1, and so on. Right, so that kind of way, by that way you can draw the graphs, and also you can observe, is this relation going to be a function? Is this relation going to be a function? Obviously no, because at x equals to 1, you are getting 1 as well as minus 1. Yes or no on this graph? So for one value of x, you are getting two values of y. That's why it is not a function. So if I give you something like this and I ask you, is this a function? Obviously no, because this guy is shooting 2 bullets, this guy is shooting 2 bullets. So even if a single guy is shooting 2 bullets, it is not going to be a function. Hence, this is not a function. And that is what we have seen in this graph. That 4 is shooting 2 bullets, 0 is shooting only 1 bullet, but 1 is shooting 2 bullets. So even if a single guy is shooting 2 or more than 2 bullets, it is not going to be a function. Okay. Which of these is a function? Yes, this is the function. Everyone is shooting and that too 1 bullet. Okay, is this a function? No, not a function, right? So that means what? For one value of x, for x equal to 2, we are getting two values of y and z. So that's why this is not a function. I hope you people understood. Okay, f is a function from a to b, and let's say it is given to me like this: f of minus 1 equal to 1, f of 1 equal to 1, f of 2 equal to 2, f of minus 2 equal to 2, f of 0 equal to 0. Now f of minus 1 equal to 1 means minus 1 is shooting 1. Minus 1 is shooting 1. F of 1 equal to 1 means 1 is shooting 1. So 1 is shooting 1. F of 2 equal to 2 means 2 is shooting 2. 2 is shooting 2. F of minus 2 equal to 2 means minus 2 is shooting 2. F of 0 equal to 0 means 0 is shooting 0. Okay. These values are also always coming from domain, and these are values of x, isn't it? And domain means what? Our army. Our army. And this is what? Opposition's army. So equal to 1, equal to 1, equal to 2, equal to 2, equal to 0. These are the values from opposition's army. Yes, here range contains 0, 1, 2 and codomain consisted of 0, 1, 2, 3, 4. 0, 1, 2, 4. Yes or no? Okay. This very same info can also be given to me like this in terms of ordered pair. Look, minus 1, 1, 1, 1, 2, 2, minus 2, 2, 0, 0. Or the same can also be written like this, because if you calculate mod of minus 1, it is going to be 1 only. If you calculate mod of 1, it is going to be 1 only. If you calculate mod of 2, it is going to be 2. Mod of minus 2, 2 only, or like this as well, right? Okay. So A is called domain. Domain is nothing values of x, but the members from the our army. B is called the codomain. Codomain means the entire opposition army, and whosoever killed in the opposition army is coming under my range. That is the values of y. Okay, if let's say something like this, ordered pairs are given. So the image of minus 2 is 2 and image of 2 is also 2. Yes or no? So image of 2 and minus 2 is 2. And by the way, I told you what will be the pre-image? Pre-image in the opposite direction and image in this direction. So image of minus 2 is 2. So we can say that 2 is pre-image of minus 2 as well, right? These technical terms I have already explained you. And those who have been killed in the opposition army is nothing but coming under my range. So in the previous example, these elements will be there in my range. Okay? Yes. So if a function is given to me like this, f is such that it is going from A to B, then A means domain and B means codomain. B does not mean range. A lot of people, take it wrongly. They say that B is range. B is not range. B is codomain. That is opposition's army. From this army only some of the members will be killed and some of the members will remain. It is possible that the entire opposition army is also killed. That means what am I trying to tell you is range is always a subset of codomain. Range is always a subset of codomain. So it is not necessary that every time range and codomain are equal, but always range will be a part of codomain only. Okay, do remember this. Okay, so the set of all elements in B which have a mapping or who have been short are called as range. Check whether following relation is a function or not. So over here the relation R is given to me like this, A set is given to me like this, so this is our army, and B set is given to me like this, so this is the opposition's army. I said fine, okay, relation R is given to me like this, 3, 8, that means 3 is killing this 8, 4 is also killing this 8, 5 is killing 10, and 6 is killing 12. This is 12 by the way. Okay, this is 12. Okay, now is this relation R a function? Yes, everyone is shooting and that too one bullet. Have a look at this. Yes sir, so this is a function. Every member is shooting and that too one bullet only. So this is a function. I hope you people understood. If I talk about domain of function, so what is the domain of the function? It is 3, 4, 5, 6. And if I talk about range of a relation, range of function, then it is going to be 8, 10 and 12. And if I talk about codomain, then the codomain means entire opposition army, means it will be 7, 8, 9, 10, 11, 12. I hope you people are clear with this. Okay, check whether the following relation is a function or not. Now this time we need to write down the relation as well. So x means the values from A, so x equal to 1 is possible, x equal to -1 is also possible, x equal to 3 is possible, x equals to 7 is possible. Y has to be from B, x has to be from A, and y equal to x square should be followed. So y equal to 1 square, that is equal to 1. Y equal to -1 ka square, that is equal to 1. Y equal to 3 ka square, that is equal to 9. Y equal to 7 ka square, that is equal to 49. So from here ordered pair is 1, 1. From here -1, 1. From here 3, 9, and from here 7, 49. Okay, in these ordered pairs, is y also from B only every time? Yes. So x has to be from A and y has to be from B. So that's why our relation R can be written like this: 1, 1, -1, 1, 3, 9, 7, 49. I said fine. Okay, is this relation R a function as well? So for that case we need to draw our army A, opposition army over here, and you see 1 is shooting 1, okay, -1 is also shooting 1, okay, 3 is shooting 9, okay, 7 is shooting 49, that's fine. So every member is shooting and that too one bullet, so this is a function. Now what is the domain of the function? This one. What is codomain of the function? This one. And I think you can observe over here range and codomain are equal in this particular function. Yes or no? Alright, let's talk about different varieties of functions. Okay, types of functions is what we are studying now. 1 function. Let's talk about this 1 function. Okay, is this a function? First do let me know, is this relation a function? Yes, everyone is shooting and that too one bullet, so this is a function. Now over here, if you look, is the fight one-on-one going on? One-on-one? No, look, in order to kill this person, 2 people are getting combined. So can we say that many people are combining to kill a single guy? Yes, so this is not a 1-1 function. Okay, over here, look, the battle is going on 1-to-1. For each person to be killed, there is only one guy. In order to kill this guy is allotted this guy. Okay, if you want to kill this, we have allotted this guy. If you want to kill this, we have allotted this guy. So over here, the battle is going on 1-on-1. So that's why this is 1-1 function. And over here, too many guys are combining to kill a single guy. So this is not 1-1. And if a function is not 1-1, it will be called as many-1. It will be called as many-1. 1-1 functions are also known as injective functions. Okay. Now look over here. For a single y, we will be getting 2 or more than 2 values of x. Yes or no? For many-1 functions, we will be having 2 or more x's for 1 y. Yes, and for 1-1 functions, if you see, this OO means 1-1. For 1 y, only 1 x. Yes or no? For one guy, only 1 x, or rather we should say unique x. Unique x. Right? Okay, if you see the graph of y equal to 2x, I hope you know the graph comes out to be like this. Now here you guys can see that if you want to see whether this is 1 1 or many 1, so for each and every value of y you will be getting a different x or not. Yes or no? If you look at the graph of y equal to e ki power x, for each and every value of y will you get a different x or not? Yes. Okay, so 1 1 and many 1 function. So if a function is not 1 1, it will be called as a many 1. Okay, so a function can be either 1 1 or many 1. 1 1 means the battle is going on 1 on 1. That means what? For every y you get a unique x, or many 1 means for a single value of y you get 2 or more than 2x. That means many people are combining to kill a single guy. Okay, so is this fight 1 on 1? In order to kill this person, only one person. Okay, yes, so this is also a function. Look, that's why we are talking about whether it is a 1 1 function or many 1 function. So it is 1 1 function. Okay, talking about this, these many guys are combining to kill a single guy. Yes or no? So this is the many 1 function. Yes. Okay, onto and into function. Another classification of functions. If onto, talking about onto is also known as surjective. If entire opposition army is dead, if entire opposition army is dead, if entire opposition army is dead, then we say that the function is nothing but onto function. That means range is equal to codomain. If range is equal to codomain, range is always a subset of codomain. If the entire opposition army is killed, then we say that range is equal to codomain. So if range is equal to codomain, then we can say that our army is on top of the game. We have killed each and every person in the opposition. That means our army is on top of the game, on tops. You can feel that that is going to be nothing but onto. Okay, so is this function going to be onto? Okay, number 1, 1 1 or many 1? It is a many 1 function because many guys are combining to kill a single guy. This is a 1 1 function. Okay, is this onto? No sir, not onto. Why? Because this person is still there, not have been killed so far. Okay, is this onto? Yes, everybody has been killed. If a function is not onto, we do call it as into. And by the way, onto is also known as surjective. On upar, sir is also upar. Right, okay, is this function 1 1 or many 1? 1 1 sir. Okay, is this function 1 1 or many 1? Many 1 sir. Okay, entire opposition army killed? No sir, that's why it's still into the war. So into, and over here if you see, this is going to be onto because entire opposition army is shot. Okay, so this function is going to be 1 1 and onto, yes or no? Is this function going to be 1 1 and into? Look, this guy is still there. Okay, if you look over here, this all the opposition are dead, so onto, and many 1 functions, many guys are combining to kill a single guy. Okay, this is many 1 and into. Okay, identify, is this a function first? Yes, everyone is shooting and that too 1 bullet. Okay, but the battle is not 1 1, it is many 2 1, and also entire opposition army is killed. So is it going to be a many 1 onto function or not? Have a look at this, everyone. Yes. Okay, now this time look, the arrows are in the opposite direction. The arrows are in the opposite direction. Okay, yes, that means this time our army is this, because every time our army shoots, and this is the opposition army. So this guy is shooting 3 bullets. So this is not even a function. Whosoever shoots is a member of our army. Okay, so this is not even a function. So we will not deal with the classification whether it is a 1 1 function, onto function, many 1. Okay, if it is not a function, we will never talk about 1 1, many 1. Okay, now if you want to find out 1 1 or many 1 functions, there are different methods. One method is through graph. Let's say I have been given this, domain is this and codomain is this, and f of x equal to x square. Let's draw the graph of f of x equal to x square. So the graph will be drawn like this, beta. Yes, okay. Now can you see that for one value of x over here, if we see, for if we take one value of y, let's say, if we take one value of y, let's say 4, what will be the values of x that I am going to get? Sir, x equal to plus 2 and minus 2. 2 values. So 2 values of y, sorry, one value of y giving us 2 values of x. So that means we can say in order to kill one person, we have allotted 2 people. Yes or no? So is this function going to be a 1 1 function or many 1 function? many one. Yes or no? Look, the domain is all real numbers, so we can draw the graph extensively to the entire x-axis, and we can say that for one value of y, we are getting two values of x. That's why this is a many one function. Yes or no? That means two people are combining to kill a single guy, if you use the analogy. So this is going to be a many one function. So what we have done over here, even if you get a single horizontal line, which cuts the graph at two or more than 2 points, then in that case, for that particular value of y, you're going to get multiple values of x. Yes or no? That is going to be many one function. I hope you people understood this concept. So that is what written over here, horizontal line test. In order to find out whether the function is one or many one, with the help of the graph, we can use horizontal line test. Even if a single horizontal line cuts the graph at two or more than 2 points, the graph will be many one, otherwise it will be one only. I hope you people understood this. This time the domain is all real numbers, positive real numbers only. Have a look at this. And if you draw the graph, this time the graph will be formed like this, because the domain is only positive real numbers. So if you do horizontal line test, is this function going to be one or many one? One. You will not get even a single horizontal line which cuts the graph at two or more than 2 points. Over here the domain is all real numbers, and you have to draw the graph of y equal to sin x. So if you draw the graph of y equal to sin x, this function is going to be one or many one. Do let me know, people. Many one function, isn't it? Because you can get even a single horizontal line like this, which will be cutting the graph at two or more than 2 points. Yes or no? Okay. Now the functions which are one as well as onto, together they are known as bijective. I hope you people know there was a special name for injective, one that is injective, and for onto there was also special name surjective. And by the way, many one and into do not have any special name. So these two people are having some special name. That's why if a function is both, then it will be called as bijective function, and for bijective functions only inverse can be written. So the inverse trigonometry that you will be studying in class 12th is entirely based on these bijective functions only, because for bijective functions only inverse can be written. Okay. All right, moving ahead. Domain of a function. Now we're gonna study in detail. Domain is what? Input, that is values of x. Okay, let's say a function is a machine, and if I do some input, that is values of x in it, I do get range, that is values of y as output. Values of y as output. Okay, let's say I have given you a function like this. Now in this machine, can you put x equals to 0? No. X equal to 0 is not allowed. Why not allowed as input in this? Because if you put x equals to 0, the denominator will become 0 over here in 1 by x, 1 by 0 it will become. So division by 0 in mathematics is not defined. So you are not going to get even a single output when you put x equals to 0. Yes or no? So this machine is not allowing x equals to 0 as the input. That means x equal to 0 is not there in my domain. So domain means permissible values of x or input for which we get an output, that is value of y. That is nothing but our domain. Okay, talking about some rules in order to solve the questions of domain. Whatever is written in the denominator, that denominator should never be equal to 0. If something is written inside under root, that under root wala thing has to be greater than or equal to 0. If log is written, then in the case of log, whatever is written over here has to be greater than 0. Whatever is written over here has to be greater than 0 and not equal to 1. Then only the logarithms term is defined. Let's say I ask you whether this is defined or not. So this is undefined, because you can never have negative number here and here in logarithms, and also here you can never have a number equal to 1. I hope you people know about this. Okay, and if let's say some plus minus is written between two functions and we need to find out the domain, and the domain of this is d1 and the domain of this is d2, then the domain of the entire thing is going to be d1 intersection d2. That is common values for which both of these are defined. then only we can say that the domain of this will be what. Let's take a few examples in order to understand this. If we talk about this, then x can never be equal to 0. So the domain of the first one is any real number except 0. Yes or no? If we talk about the second one, then the denominator should not be equal to 0, means x minus 1 should not be equal to 0, means what? It can be any real number, x can be any real number except 1. Yes or no? Okay, talking about the third one, the denominator should not be equal to 0. That means x should not be equal to 3 and minus 3. Yes or no, everyone? Do let me know. Yes, so x cannot be equal to 3 and minus 3. I hope you guys are clear with this. Rest x can be anything. Okay, AIEEE 2011, this question was asked. How many of you guys can tell me the answer in like 5 seconds? Do let me know. Come on kids, come on. The answer of the problem is going to be B for Bombay. Okay. You must know the few things that I am going to write down. Mod of x minus x is always greater than or equal to 0. For the solution of this is x belonging to R. Okay. Mod of x minus x is greater than 0. So the thing is x belonging to R minus. For all negative numbers, this is going to be there. Okay. Mod of x equal to x, the solution is going to be what? X belonging to 0 to infinity. Okay, I hope you people know about this. And x greater than mod x is never possible. X belongs to null set. Okay, you need to remember this. These are very important and very basic things which you must. Okay, you can solve this question objectively as well. You can take any negative value and put it over here. So denominator is getting defined, yes or no? Yes, so that means negative value has to be your answer, but rather if you put positive value, no positive value is satisfying this inequality. That means whatever is written inside the under root has to be greater than 0, but also it is written in the denominator, so equal to 0 wala sign has been removed. Because whatever is written inside the under root has to be greater than equal to 0 and the denominator should never be equal to 0. Both the conditions are there. So from there I have written this condition. I hope you guys are clear. Okay, talking about this, whatever is written inside the under root has to be greater than or equal to 0, means x belongs to 0 to infinity. Okay, talking about this, x square minus 9 should be greater than or equal to 0. If you solve this, then you can solve it by Wavy-Curve method. X plus 3 times x minus 3 is greater than or equal to 0, and you can say that x belongs to minus infinity, say minus 3 union 3, say infinity is the domain of this particular expression. If you put any other value of x in this apart from this, then the expression is going to be undefined. Okay. Talking about this, whatever is written inside the under root has to be greater than or equal to 0. If you multiply both the sides of inequality by a minus sign, sign of inequality changes. So you're going to get something like this. So x belonging to minus infinity, say 2 union 3, say infinity. Yes, that's it. So this is our answer. The domain of the function is going to be what? Okay, sorry, the sign has to change because we have multiplied both the sides by a negative number, so sign of inequality has to change. So x belongs to 2 to 3. Right? I hope you guys are clear with this. It's a portion that you have studied under basic mathematics. So I hope you should be clear with that. Okay, talking about the logarithmic terms, E is Napier's constant. Its value is roughly equal to 2.71. So that value is already greater than 0 and not equal to 1. I hope you people know about this. So over here in the first part, you can see that x minus 1 has to be greater than 0. No other thing is there. So x has to be greater than 1 means the domain of this is what? X belonging to 1 till infinity. Okay, talking about the second one, only one condition is there. X square minus 5x plus 6 has to be greater than 0. If you factorize this, you can write it like this. And from here you can say that x belongs to minus infinity to 2 union 3 to infinity. Yes or no? So that is your domain. Talking about the third one, x has to be greater than 0 and not equal to 1 means, because whatever is written over here should be greater than 0 and not equal to 1. So x belongs to 0 to 1 union 1 to infinity is the domain of the third one. Yep. Okay, the domain of the function defined by this particular thing. So look, over here both variables are there. x plus 1 over here and x is over here. Okay, number 1, whatever is written over here has to be greater than 0. Number 2, whatever is written over here has to be greater than 0 and not equal to 1. So we are basically dealing with 3 inequalities. The first one being this, I said okay. The second one being this, and the third one being x is not equal to 1, means x can be any real number except 1. So this is 3. Now all the 3 conditions has to be satisfied, then only I will say that my entire expression is defined. So the domain is going to be 1 intersection 2 intersection 3, that is the common values in all these 3. So what are the common values, kids? The common values are going to be 0 to 1 union 1 to infinity. So that is where your expression is defined, otherwise not defined. Okay. Alright, if this function is having domain D1 and if this function is having domain D2, then plus minus is written in between the two functions, then the domain will be D1 intersection D2. That, for example, for this we have seen domain was 2 to 3, and for this we have seen that domain was 0 to 1 union 1 to infinity. So we have to take the intersection of 1 and 2 over here to get the final domain. So the intersection of 1 and 2 is going to be what? 2 to 3 only. So over here the domain is going to be this. I hope you people understood this. There has to be no issue at all. Okay, domain. One thing is whatever is written inside the under root has to be greater than 0, and another thing is denominator should not be equal to 0. So if you want to apply these things together, or if you want to take intersection of these, then we can write it like this, yes or no, and then we know how to solve this. So it is going to be x plus 3 times x minus 3 greater than 0. So the answer is going to be x belonging to minus infinity, say 3, minus 3 union 3, say infinity. Right? So the domain can comfortably be written. Okay, over here, if you see, the domain of this will be minus infinity, say minus 3 union 3, say infinity, and the domain of this is going to be x greater than 4. So just take the intersection of these two, you will get the answer. I hope there has to be no issue with you people. The domain will be 4 till infinity, the intersection of these two. That is the common values. Right? Okay. Now, do the following two functions have same domain, 1 and x by x? Over here, whether you put x equals to 0, the machine is going to give you y equal to 1 as the output. Over here, whether you put x equals to 2, the machine is going to give you y equal to 2 because there is no x, yes or no? But if in this machine, can you put x equals to 0 or not? No output, yes or no? So I hope you guys can feel that these two things are different. A lot of times what happens, kids first cut these two and they say, sir, both are equal 1 1, that's why they do have same domain. No beta. Here in this expression you cannot put x equals to 0 because at x equals to 0 denominator becomes equals to 0. So these are two different expressions. Okay. While solving any question or inequation, always take care of the domain, because your solution has to be subset of your domain, because first your expression will be defined and then only your equation will be satisfied, right? So always your answer must be, or your solution must be subset of domain. Okay, subset of domain. Whatever is written inside the under root has to be greater than or equal to 0, yes or no people? So you can do it like this. Then over here you can write x minus 1, x minus 3 upon x minus 1 greater than or equal to 0. Now over here, if you see closely, x equal to 1 will not come in the domain, right? So do write it down. If you are cutting it, then over here write that x cannot be equal to 1, because the moment x becomes equals to 1, then the denominator becomes equals to 0. So over here you need to write down the solution x belonging to 3 to infinity, where x should not be equal to 1. So over here already x equal to 1 is not included, so the final answer will be x belonging to 3 to infinity only. Okay, over here x minus 3 upon 4 minus x square has to be greater than or equal to 0. We can write it down like this. Sign of inequality changes, we have multiplied by a negative number, then x minus 3, over here x plus 2, over here x minus 2 is less than or equal to 0. If you do a number line, then over here it will be what? Minus 2. Over here it will be 2. and over here it will be 3. By the way, x can be equal to 3 but not denominators can be 0. So denominator cannot be equal to -2 and -3. So I hope you know wavy curve method. The moment you apply it, you want negative. So x belongs to minus infinity, say -2 union 2 to 3. I hope you guys are clear with this. Open 2 to closed 3. Yes? Okay, talking about the third one, whatever is written inside the under root has to be greater than or equal to 0. You can solve it like this as well. You can take under root both the sides. Under root x square is what? Mod x, people. Under root x square is what? Mod x. And I hope you know the distance that you have to travel from 0 has to be less than or equal to 2, means x belongs to -2 to 2. You would have solved this in multiple different ways as well, but let me tell you this way as well because you need to understand these concepts as well. Okay, talking about this, whatever is written inside the under root has to be greater than or equal to 0. So this thing we have applied for this particular term. Okay, but there are two under roots. So we need to make this thing also greater than or equal to 0. Okay. So let's solve these two equations. So from 1, if you see 4, say this has come. Okay, if you square both sides, you're gonna have something like this. And x square can be over here and over here -12 will come. So this is x belonging to R, not an issue. Talking about this from 2. So if you do this over here, this will come, and we have already seen the solution x belonging to -2 to 2. So the final answer will be 1 intersection 2. Final answer will be 1 intersection 2. So that is what? X belonging to -2 to 2. Now I hope you guys can do this question as part of homework. Do let me know the answer below. Okay. Yes, let me call this question as star 1. Okay. Alright, find the domain of these particular expressions. So 4 minus 2 over mod x should be greater than 0 or equal to 0. So this will be 4 greater than equal to 2 and this. If you divide both sides by 2, the inequality will become something like this. Now x cannot be 0, mod x can never be negative, so you can cross multiply, so you can write down the same thing. And that means what? X belonging to minus infinity, say -1 by 2 union 1 by 2 to infinity. I hope you guys are clear with this. Do solve this question on your own as well. Over here mod x has to be greater than 0, so x belonging to all real numbers except 0 will be the answer, because the only number at which mod x becomes equals to 0 is nothing but x equals to 0 only. Okay, over here this thing has to be greater than 0. So over here mod x, if you take common, over here mod x -1 will come, and if you draw over here 0 and 1, so positive, negative, you only have to look between the values greater than 0 only, because mod x is always positive, right? So you can say that mod x belongs to 1 till infinity. That means x belongs to where to where? X belongs to minus infinity to -1 union 1 to infinity. I think there has to be no issue at all in order to solve these questions. Okay, greatest integer functions involving domain. Okay, so these values has to be greater than equal to 0. If you factorize it, you can write it like this, bacha party. Okay, so over here you can say that greatest integer of x is less than or equal to 1, or greatest integer of x is greater than or equal to 3. So over here if you see x belonging to 3 to infinity will come. I have already told you how to solve these kind of questions. And over here if you see x belonging to minus infinity, say 0 per open will come, no, 2 per open will come. Yes, or so final answer is union of these two. Final answer will be union of these two. X belonging to minus infinity, say 2 union 3, say infinity, right? Yes, because I have already talked about these things in basic mathematics. If you are still not clear with the method, you can go and watch basic mathematics session. Greatest integer of x -4 is greater than or equal to 0 gives greatest integer of x being greater than or equal to 4. The solution of this is x belonging to 4 to infinity, closed 4. If you talk about this, greatest integer of x should be greater than or 0, and sath it should not be equal to 0 since it is coming in the denominator. So the intersection of these two is going to be something like this. The intersection of this is going to be something like this. So we can write it also like this, because greatest integer of x is always an integer. So greater than 0, what is the least integer possible? 1. So we can write down the solution of this as x belonging to 1 to infinity. This is a very, very, very important questions which I am doing for you people. You have to take care of these questions in the examination hall. Okay, domain over here is x belonging to R. There is not an issue. Over here also x belonging to R, because I hope you know fractional part of x goes from fractional part of x, since fractional part of x belongs to 0 to 1 only, so not an issue. Okay, talking about this, x belonging to all real numbers minus integers, because at integers fractional part becomes equal to 0. That's why. And over here denominator should not be equal to 0, right? Okay, find the domain of this. So over here only one condition, x greater than 0. So this is the domain. Over here if you see, for this term, this expression has to be greater than 0, and for this logarithm also, if you see, this has to be greater than 0. So both of these things has to happen, and whenever the base of the logarithm is greater than 1, the sign of inequality does not change. So over here you can write like this. So taking the intersection of these two, what is the intersection of these two? 1 intersection 2 will be your answer, that is your answer will be x greater than 1, right? Yes, whenever base of the logarithm is greater than 1, sign of inequality does not changes. Okay, so for this you can do number 1. Okay, this thing should be greater than 0. Number 2, if you see, this thing should be greater than 0. And number 3, if you see, this thing should be greater than 0. So this is 1, this is 2, this is 3. Take the intersection of these 3, you will get your final answer. So the intersection will be coming out to be what? Let me tell you, 10. X should be greater than 10. Okay, this is the final answer. Similarly, you guys can solve this question at your home now. So star 2 is what I am calling it. You have to solve it on your own, bacha party. Okay, the domain of this function is what you want to find out. It's a JEE main 2019 question. I hope you know that denominator should not be equal to 0, number 1, and whatever is written over there, x cube minus x has to be greater than 0. So if you do this, x times of x square minus 1 greater than 0, over here you can see x times of x plus 1 into x minus 1 greater than 0. Just do wavy curve method, your question will be solved. Minus 1, 0, 1. So positive, negative is what you're gonna get. You want positive numbers. So from here, x belongs to minus 1 say 0 union 1 say infinity, but over here x is not equal to 2 and minus 2. So from here remove 2. From here remove 2 and minus 2. Minus 2 to already hai nahi, that means you need to remove 2. So minus 1 say 0 union 1 say 2 union 2 say infinity will come out to be your answer. Look, this was a problem asked in JEE Main 2019. Okay, talking about this, the function, the domain of the function, this is what is going to be what? Okay, 2 to the power x equals plus 2 to the power y equal to 2. That means 2 to the power y can be written as 2 minus 2 to the power x. I hope you know that an exponential thing is never negative, so this thing is never negative. Never negative. If this is never negative, then the right hand side should also be never negative. If right hand side is never negative, that means this number has to be less than. This number has to be less than or equal to 2. Less than or equal to 2. So I hope you know that if this number is less than or equal to 2, then x can be what? It can go from minus infinity till 1. C for Calcutta will be the answer. So is this going to be your domain or not? Yes or no, everyone? I hope you guys are clear with this. Okay, let's talk about range of a function. Range. I hope you people know that sin x goes from where to where? Sin x goes from minus 1 to 1. So its modulus will go from where to where? Whenever a function you know, a thing you know which goes from somewhere to somewhere, and you want to find out its modulus will go from where to where. So what you need to do is you just have to take one number line and over here let's say 0. So it is saying that my sin x is going from -1 to 1. Mod of that thing will go from where to where. So what you do is simply cut your number line from origin and just rotate the negative axis portion like this. So the moment you rotate it, that portion will look something like this. So -1 will come over here and this entire region was there. So wherever, now you have to look for the value of mod of sin x, you have to look on the right hand side. Out of these two lines, wherever the farther the color is, you have to write it down. It does not matter whether in the upper line or in the lower line. Okay. So over here you guys can say that mod of sin x will go till 1 and it will start from 0. So the range of this is going to be this. In the second part also same thing is going to happen. Mod of cos x will go from 0 to 1. Okay. Tan of x. Tan of x goes from where to where, beta? Tan of x goes from -infinity to infinity. So here, if you do mod of tan x and if you cut it from the origin, don't you think that it will go from 0 to infinity? Everyone do let me know, including 0. So your range is going to be 0 to infinity in this case. 0 to infinity in this case. Over here it is 0 to 1. Over here it is also 0 to 1. I hope you guys are clear with these. Okay, talking about this, I hope you people know that cosec x belongs to -infinity say -1 union -infinity say -1 union 1 to infinity. So if you take mod of cosec x, can you say that it will go from where to where? Till infinity. Yes or no? So the answer of this is clear. Similarly, E, mod of cot x goes from 0 to infinity, beta, and mod of sec of x on the same pattern as mod of cosec x only goes from 1 to infinity. I hope you guys are clear with all these 6 terms. Okay. Now talking about this, we know that sin x goes from where to where? Sin x goes from -1 to 1. Then 2 sin x will go from where to where, beta? -2 to 2. Yes or no? We have multiplied both the sides of inequality by 2. The sign of inequality will remain same because 2 is a positive number. Now if I am asking about 2 sin x ka modulus, is it going to be 0 say 2 ke beech mein or not? Everyone do let me know. Okay, talking about the B part, if you look about the B part, then mod of tan of x, we have already seen that it will go from 0 to infinity. So we can say that mod of tan of x is going from 0 to infinity. So twice of mod of tan of x will go from where to where? So we need to multiply each and every side by 2. By the way, 2 into infinity is 2 only, 2 into 0 is 2 into infinity is infinity only. Yes or no? Yes. So the range is going to be between 0 to infinity only, not an issue. Right? Talking about the third one, bete. We know that 2 cos x will go from -2 to 2. Yes or no? So its modulus will go from where to where? Do let me know. 0 to 2. Yes or no? Okay, plus 3 is what I want to do so that I can make the exact same expression. So this will be going from where to where, beta? 3 to 5. Yes or no? Anyone is having any issue in this? Okay, similarly, you guys know that mod of cos x will go from 0 to 1. So this will go from 0 to 3. So this will go from -3 to 0. I hope you can find out the answer. Yes, everyone? Okay, so I hope you people have got the answers of this. Moving on to the next thing. Okay. Now, for quadratic expressions, you need to understand one thing. How to draw the graph of y equal to x square minus 4x plus 3. I hope you guys know. The roots are 1 and 4. And coefficient of x square is greater than 0. So the graph will be opening like this. Yes or no, beta? This is the graph of y equal to mod. Okay, 1 is coming over here. That means 0 will come somewhere over here on the left. Like this. So this is your y axis. This is your x axis. I said okay. And this point is always minus b by 2a comma minus d by 4a. Minus b by 2a comma minus d by 4a. So it is going to be 5 by 2 comma how much? Minus d by 4a. If you calculate for this, So 16 minus 4 into A into C. So 4, so minus 4 by 4 into 1. Minus 1 is the answer. Yes? Okay. So the lowest point for this particular expression is nothing but minus 1 on the y-axis. And then it is going till infinity. So the range is going to be minus 1 till infinity. Okay, now if I want to draw the graph of this, what do we do? Whenever the expression is written completely inside modulus, mod of x square minus 4x plus 3, so we need to remove the portion which is coming below x-axis and take its mirror image about x-axis. So this is going to be the complete graph for the second one. So this point will now become 5 by 2 comma 1. Okay, so over here if you see, the value is going from 0 to infinity only. Okay, talking about the graph of the third part, we have seen that y equal to x square minus 4x plus 3 will be looking something like this. Okay. Yes, now whenever x is replaced by mod x, the graph becomes symmetric about y-axis. Okay, so whatever the graph is coming in the positive x-axis, just draw the same graph over here as well. Remove the portion which is coming in the left of the graph and then take the mirror image about y-axis of the graph which is drawn in the positive x-axis. So over here also the range is going to be same, minus 1 to infinity only, because this point is going to be 5 by 2 comma minus 1. So this point will also be minus 5 by 2 comma minus 1. Okay, so that is how we do the graph transformations. I hope you people have gone through that. Okay, over here it will go all real numbers, over here it will go 0 to infinity. There has to be not an issue about this, and over here minus 2 to infinity, because x is a real number. If x is a real number, it will go from minus infinity to infinity, and plus 1 plus 1 plus 1 if you do, then minus infinity plus 1, samudra mein ek glass pani is always going to be that C only. So this is going from there to there, then its modulus you guys can evaluate, and then minus 2 you can take. There has to be not an issue. Okay, there will be not an issue, any issue. Sin x goes from minus 1 to 1. Okay, but this time it is asking me about greatest integer of sin x. Now understand, greatest integer of sin x has to be an integer value only. So how many integer values are possible inside this, or for the values like this? I think you can see that the greatest integer values possible will be nothing but minus 1, 0 and 1. Yes or no beta? Because the thing written inside the, you can feel it like this, that sin x is going from minus 1 to 1. That means all these values sin x can take. So for this value, if I talk about the greatest integer will be the same value. For these values, if I talk about greatest integer, the greatest integer will be this value. For this particular value, the greatest integer will be this itself. And for these values, the greatest integer will be what? These values. And for this particular value, the greatest integer will be this. Yes or no? Everyone feel it? So the question number 1 is done. Similarly, question number 2 can also be done, because minus sin x will also go from minus 1 to 1 only. So this will be minus 1, 0 and 1 only, not an issue. 2 minus sin x. So if my 2 minus sin x will go from where to where? You just need to add 2 to both the sides. So it will go from 1 se lekar ke 3. Yes or no? So its ka greatest integer function will go from where to where? It will go from 1, 2 and 3. These are discrete values. That's why I am writing down it in curly bracket, because greatest integer of anything has to be an integer only. I hope you people are aware of this very important property, right? Okay beta, we have just seen that 2 minus sin x belongs to 1 se lekar ke 3. The mod of 2 minus sin x will also go from the very same values only. And if we are talking about the greatest integer of these values now, so it will also go from 1, 2 and 3 only, right? Okay. And if I ask you E part, that is twice of greatest integer of mod of 2 minus sin x. So every value will get twice, yes or no? So this value, if I am multiplying by 2, will become 2, then 4, then 6. So I hope you guys are clear with all these examples. There has to be no issue at all. Okay, fractional part of anything goes from 0 to 1. Okay, so in the A part the range will be what? 0 to 1. Okay, fractional part of anything goes from 0 to 1. Okay, but this is different. There is a difference between these two. Fractional part of x goes from 0 to 1. In the third part, now we have to multiply 2. So if we multiply 2 in all the sides, 2 is a positive number, so sign of inequality will remain same. So what you're gonna have is 2 times of fractional part of x will be going from 0 se lekar ke 2. So that is the difference between B part and C part. Okay. Yes, I hope you guys are clear with this. Okay. Talking about the same thing, fractional part of anything will go from 0 to 1. So the answer of this will go from 0 to 2 because 2 is written in multiplication. Then minus 3 if you do, so it will be minus 3 se lekar ke minus 1. I hope you guys are clear with this. Okay, if x is going from 0 to 2, if x is going from 0 to 2, 0 to 3, okay, x is going from 0 to 3 in the A part, then it is saying me greatest integer of x square will go from where to where? So x square will go from 0 to 9. So its greatest integer will be all the integers possible in between. That means 0, 1, 2, 3, 4, 5, 6, 7, 8 and including 9 as well. Yes or no, beta? I hope this is clear to all of you guys. In the B part, if you see, x is going from 1 se lekar ke 9. The question is asking me about root x. So I need to take root in all the 3 sides. So it will be going from 1 se lekar ke 3 tak. So the greatest integer values possible are, and integers between these, so 1 and 2 are the only integral values possible. Yes or no, beta? Okay, talking about this, these are discrete values, so not any issue. At x equal to 1, you're going to get 3. At x equals to 2, you're going to get this, 3 and 4. Quite an easy problem because these are discrete values. Okay, but let me tell you the graph of this. You might have studied the graph of these kind of functions looks like this. Yes or no? So over here you guys can see at bigger x, you get bigger y. Yes or no? At greater x, we get greater y, Yes or no? So over here, if you see in the B part, x is going from 0 till 2. So at x equal to 2, if you see, you're going to get the maximum value, and at x equals to 0, you're going to get the minimum value. Yes or no, beta? So over here, when you put x equals to 0, that is the minimum value, you get the minimum value for the function. And at x equals to 2, you get the maximum value. So it will go till 3 to the power 2. 3 to the power 2 is, by the way, 9, and this is 1. So 1 to 9 it will be going. Over here, if you see, same thing is going to get followed because the function is increasing. Increasing means at greater x, you're going to get greater y. So this kind of a thing will be there. So this will be 1 till infinity. 3 to the power infinity is, by the way, infinity, in case you don't know. Okay, over here, if you see, it will be 3 to the power minus infinity till 3 to the power 0. 3 to the power minus infinity, as per the limits, you guys can easily identify that that is equal to nothing but 0. So it will be going from 0 to 1. Over here, if you see, it will be 3 to the power minus infinity till 3 to the power infinity, that is, it will be going from 0 to infinity only. Yes or no, beta? Okay, talking about this now, sometimes what happens that in the exponential function, x is not written, some other power is written. Some other power is written in place of x, So over here, what you do, since the base is greater than 1, so at bigger power, you get bigger y. Now understand this. Whenever such kind of questions are there, you need to first calculate that your power is going from where to where. So in the first question, if you see, your power x square plus 2 will be what? Your power x square plus 2 will be 1 square plus 2. 2 square plus 2, 3 square plus 2 and 4 square plus 2. Once you have an idea about the power, that will be going from 3, then 6, then 11, then 18. Just put this power simply in the question, you have got your answer. So it will be 3 to the power 3, 3 to the power 6, 3 to the power 11, 3 to the power 18. These will be your range. Understood? Okay, talking about the B part, x square plus 2 will go from where to where if your x is going from 0 to 2. If your x is going from 0 to 2, your power will go from where to where? Can you evaluate that, kids? Yes, that will go from 2 to 6. So we know at bigger power for x belonging to 0 to 2, this expression goes to 2 to 6. Yes or no? So the moment you have got this, then you can say that the expression will go 3 to the power 2 till 3 to the power 6. At the least value of power, you can get the least value of y. At the greatest value of power, you are going to get the greatest value of y. Okay. In the C part, if you see x square plus 2 will go from where to where? If this is going from, okay, 2 to infinity, for x belonging to 0 to infinity, because x square is always greater than or equal to 0. I hope you people are aware of this. So 3 square till 3 to the power infinity, and I hope you guys know that 3 to the power infinity is nothing but infinity only. Right? Okay, talking about this, if x is negative, then x square plus 2 will again go towards, for x belonging to minus infinity is 0. Yes or no, beta? If that is the case, then your question is done. So it will be going from, okay, so it will be going till 0 to infinity only. So over here also 3 to the power 0, say 3 to the power infinity. 3 to the power infinity is, by the way, infinity only. And over here if you see, so if x is going from minus infinity to infinity, so x square will be greater than or equal to 0. So x square plus 2 will be greater than or equal to 2. So it will go from 2 to infinity. Yes or no? So the answer over here is 3 to the power 2 se lekar ke 3 to the power infinity. Right? I hope you people understood this. Okay. Okay, over here 2 will come, sorry. Yes, 3 to the power 2 till 3 to the power infinity. Right? Okay, talking about this, at bigger x, you get lesser y. At bigger x, you get lesser y. You get lesser y. At bigger x, you get lesser y. Yes or no? Why? This is because this is a decreasing function. The graph of this expression forms like this. Yes or no? Okay, so over here if you evaluate, it will be 1 by 3 to the power 1, 1 by 3 to the whole power 2, 1 by 3 to the whole power 3 and 1 by 3 to the whole power 4 will come. These are the discrete values you're gonna get. Okay, since the base is between 0 to 1. Base is between 0 to 1, that's why. Okay, so at bigger x you get lesser y, so 1 by 3 to the whole power 2 till 1 by 3 to the whole power 0 will be your answer. I hope you people understood this. At bigger x we got lesser y and at lesser x we got bigger y. I hope you people understood this. Moving on to the third one, at bigger x you're gonna get the lesser y, so 1 by 3 to the power infinity and then 1 by 3 to the power 0. Okay, this value is included, that's why I'm including this value, and this value is not included, that's why I have to make an open bracket over here. Now if you see the value of 1 by 3 to the power infinity, that will be equal to 0 and 1. Yes. Okay, I hope you have studied this thing in limits, chapter limits. That's why I'm not explaining too much over here. Now these two questions you guys can do as part of homework. I'm marking it as star 3 homework. Do let me know the answer of these questions in the comment section below the video. Okay. Alright, now you need to know about x square plus x plus 1. X square plus x plus 1 goes from where to where if your x is going from x is 1, 2, 3, 4 in the A part. So you guys can see 1 square plus 1 comma 2 square plus 2 plus 1 comma 3 square plus 3 plus 1 comma 4 square plus 4 plus 1 like this. So these numbers are going to be what? These numbers are going to be 3. Therefore, x square plus x plus 1 in the first part is either 3, 2 to the 4, 5, 6, 7, then 3 to the 9, 12, 13, and then 21. So the answer or the range will be what? The range will be 3 to the power 3, 1 by 3 to the power 3, 1 by 3 to the power 7, 1 by 3 to the power 13, and so on. I hope you people understood this. And 1 by 3 to the power 21. Yes, any issues? Okay, now you have to draw the graph of, let's assume power as something t equal to this x square plus x plus 1. I hope you can draw the graph of x square plus x plus 1. So the graph will be drawn like this. Okay, yes, this point will be x equal to minus 1 by 2. Okay, and this point I hope you can evaluate, minus d by 4a, so 3 by 4. Okay, so over here you see it is saying that between x equal to 0 to 2, between x equal to 0 to 2, that means you have to keep only this graph. So this value you can evaluate at x equals to 2, that value was 7, and at x equals to 0 the value was 1. So over here you guys can see that in the B part, x square plus x plus 1 is going from 1 till 7. So you know that 1 by 3 is written in the base, that means you're going to get the lesser value when the power is 7, and when the power is least, that is 1, you're going to get the greatest value. So this will be the answer of the second one. In the third one, if you see 0 to infinity, 0 to infinity, that means what? X square plus x plus 1 is going from 1 till infinity. Because this time you have to observe this entire graph. This entire graph. Yes or no? Right? So if that is the case, then the least value will be 1 by 3 to the power infinity and the greatest value will be 1 by 3 to the power 1. When the power is greatest, the number will be the least, and when the power is least, the number will be the greatest in the case, because the base is between 0 to 1. Okay, these questions are for your homework. Star 4, you guys can definitely solve these questions. Right? Okay. Yes, let's have a look at this. I hope you people know the graph for these ones. Since the base is greater than 1, so the graph will be forming like this. So at greater x, greater y. Simple logic, the same logic you can follow and can do these questions. I think there has to be no issue at all. Talking about this, the same thing was happening in the base. If x square at x equals to, at greater value of x square plus x plus 1, we get greater value of y. Why? Because the base is greater than 1, that's why. And the rest of the things are same. So you guys can do it. Over here at greater x we get lesser y, at greater x we get lesser y, because the base is between 0 to 1, right? I hope you can do that. And over here also at greater x square, at greater x square plus x plus 1 we get lesser y. That's it. So first know about x square plus x plus 1 and then your question will be solved. Okay, talking about this, over here a part x goes from minus infinity to infinity, so minus 1 if you do, the range will be all real numbers only, not an issue. If you do the reciprocal in this part, so reciprocal will be going from it cannot be 0, that's it, because if something is 0 then the numerator has to be 0, then only the thing will be 0. Okay. Okay, in the third part, I think you can have an idea about x square, then you can have an idea about 1 plus x square, and then you can have an idea about the reciprocal of that the reciprocal of that will be less than 1 and greater than 0, because it is a positive number only. So, The range will be between 0 to 1, open 0 to closed 1. Yes? Okay, talking about this, y is equal to 1 minus 2 by 1 plus x square. So we have just got about this 1 upon 1 plus x square. That this will be going from 0 to 1. If you do minus 2 multiplication in both the sides, sign of inequality will change. And then if you do plus 1 in all the sides, your expression will be created. So this value will be what? This value will be minus 1 till 1. So closed on minus 1 and 1 per open. I hope you guys are clear. And by the way, D and D are same. E are same. Just simplify D, you will get to know that D and E are same. So instead of this, this can also be asked. So you need to convert like this and then your range can be comfortably find out. Okay. Yes, over here if you want to find out range, so it has to be 0 to infinity only. This has to be 1 to infinity, because I hope you guys know that x square goes from this, then plus 1 if you do, so it is x square plus 1 is greater than or equal to 1, taking under root in both the sides. This is y is greater than equal to 1 means 1 to infinity only. Okay, talking about this, it will be 3 to infinity, yes or no everyone, think over it. Okay, and talking about this, it has to be 0 to infinity. You can do it on your own. Okay, this one if you do, it will be between 0 to 3. This one if you do, it will be between 0 to infinity. Okay. Yes, these questions I hope you guys can solve. The method is quite simple. Whenever you have quadratic upon quadratic or quadratic upon linear or linear upon quadratic, you have to follow the algorithm that I am about to give you now. What's the algorithm? First, assume y as constant and cross multiply. So the moment you cross multiply in the A part, you guys can write it like this. Now, assuming y as constant, you have to form a quadratic in x, means you have to take together the terms of x square. You have to take the terms of x together and you have to take the constant terms together. So this is what we are having. Now look, is this a quadratic equation for all the values of y? No. When y is equal to 1, this is not a quadratic equation, and when y is not equal to 1, this is a quadratic equation. Okay, so let's come to the agenda. That when y is not equal to 1, this is a quadratic equation, and if I want to find out range, so y has to be real. Y will be real only when x is real. Yes or no? So discriminant has to be greater than or equal to 0. So that means what? Minus y minus 1 ka whole square minus 4 into y minus 1 ka whole square should be greater than or equal to 0. So over here you guys can write it down like this as well, and this 4 if you take inside, it will become 2y minus 2 ka whole square greater than or equal to 0. Now here you can apply a plus b into a minus b. The moment you apply a plus b into a minus b, you're going to have something like this. Greater than or equal to 0. So over here you're going to have 3y minus 1, and over here it will be 3 minus y greater than or equal to 0. You can multiply both the sides by minus sign, you will get something like this. And if this is the case, then you're going to get y belonging to 1 by 3 se lekar ke 3. Okay. Yes. Now solving this green part. When y is equal to 1 is there, so the equation becomes 0 into x square minus 2x plus 0 is equals to 0 gives 2x equals to 0 gives x equals to 0. Yes or no? So you are getting y, for y equal to 1, you are getting x equals to 0. That means over here if you put x equals to 0, you're gonna get y equal to 1. So y equal to 1 is also there in your range. If it is not included over here, if that is not included over here, then you have to include y equal to 1 as well. But since over here y equal to 1 is already included, so you have to keep that as the answer, because y equal to 1 is already included. So the answer is 1 by 3 till 3. Understood everyone? Yes, any issues of whatsoever kind? Similarly, the second problem can be solved, but the second problem can be solved in another way as well. One method is this, you can apply it. Let me tell you the another method for second question. Y equal to x square plus x plus 2 divided by x square plus x plus 1. If that is the case, then you can write down the same question like this as well. Have a look at this. And then you can write down this particular thing like this as well, beta. And over here, if you see x square plus x plus 1, this will be going from where to where? It will be going from 3 by 4 to infinity. So its reciprocal will go from where to where? Can you tell me, beta? Its reciprocal will go from 0 to 4 by 3. If that is the case, then 1 plus this will go from where to where, beta? So this will go from 1 से लेकर के 7 by 3. Yes or no? And over here no equality is there. Right, so this is another method. I hope you guys are clear with this. This is method number 2. This is method number 1. You guys can do it like this as well. The answer was coming out to be 1 say 7 by 3. And by the way, 1 was open. Yes, this will be the answer. I hope you guys are clear with the method number 2 as well. Talking about the method number 3. Okay, over here the thing is going to be same. So not an issue. These questions I'm leaving as part of homework. I think you can definitely solve it. There has to be no issue at all. Then 3 sin x. Sin x will go from minus 1 to 1. So 3 sin x has to go from minus 3 to 3. Then plus 2 is also there. So do plus 2. You can see that the first part is going from minus 1 till 5. Yes or no? Okay, if you want to take the reciprocal of this. So I have told you one thing. And what's that? Whenever you have to take the reciprocal, and if one side positive and one side negative number is there, just split it around 0 first. So split it around 0 first and then take the reciprocal. You're gonna have no issue at all. So now if you take reciprocal, plus 2 is also here, plus 2 is also here, plus 2 is also here. Okay, now if you do the reciprocal, so over here it will be minus 1. And over here it will be minus infinity. Over here it will be 1 by 5. And over here will be infinity. So you have got the range. So your range in the B part is going to be like this. C part is quite an easy one. So there has to be no issue at all. Okay, this is A part and this is B part. Okay. Alright, then similarly you can do all these questions as homework. There has to be no issues because we have already seen how to calculate the powers. So calculate the powers individually and put the values, that's it. This is going from, power is going from 0 to 1. I hope you know the remaining thing. Okay. In trigonometry you might have studied this, A sin theta plus B cos theta. So A sin theta plus B cos theta is going from minus under root A square plus B square till plus under root A square plus B square. Yes or no? So over here you can see that in the first part this can be applied. So the expression will be going from minus 5 to 5. So its modulus will be going from obviously 0 to 5. Yes or no, everyone, do let me know. Okay, minus 2 has been done. So minus 7 to 3 it will go. So okay, sorry, 0 to 5 it will go. So minus 2 to 3 it will go. Okay, here also I think the power is clear that the power is going from mod of 3 sin x plus 4 cos x is going from where to where? It is going from 0 to 5. So we know that at greater power we're gonna get the greater value. So 3 to the power 5, and at lesser power we're gonna get the lesser value. So done. Okay, similarly you can solve these questions as homework. There has to be no issue at all. Okay. Yes, now we're gonna quickly have a look at even functions and odd functions. I hope you know the graph of even functions. If f of x is equal to f of minus x, if f of x is equal to f of minus x, then we say that the function is even function. If f of x equal to f of minus x, then we say that the function is even function. Even function is symmetric about y axis. What is the meaning of this? If a comma b is lying on the curve, then minus a comma b will also lie on the graph. That is what meant by having symmetric about x-axis. What is a odd function? F of minus x is equal to minus times of f of x. F of minus x is equal to minus times of f of x is nothing but an odd function. Then odd function's definition is what? It is symmetric about origin. What is the meaning of symmetric about origin? If a comma b is lying on the curve, then minus a comma minus b will also lie on the curve. Okay, a function may or may not be even or odd. Like this function, it is neither even nor odd. Okay, let's check whether this function is odd or even. If you are not able to visualize the function, then let me tell you it is x square plus 4. Okay, if you do f of minus x, f of minus x means you just need to replace every x by minus x. So the moment you do this, it is going to be x square plus 4 only. Therefore, f of x is equal to f of minus x. Since this is there, we can say that it is an even function. Anyone is having any doubt in this? Feel free to reach out to me, beta. Okay, talking about this, f of x equal to x cube minus x. Can you calculate f of minus x? Yes, sir. Simply replace x by minus x. So the moment you do that, it is going to be minus x ka cube plus x. So it is equal to minus times of f of x only. So therefore, f of minus x is coming out to be equal to minus times of f of x. So therefore, we can say that it is an odd function. Yes, everyone. Okay. Moving ahead, talking about this. This is our f of x. So our f of minus x will be what? You simply need to replace x by minus x. So this is what we're gonna get. If you add these two, then you can say that the summation is equal to 0 because ln a plus ln b is equal to ln ab. So f of minus x is coming out to be equal to minus times of f of x. You will say that f of x is nothing but an odd function, right? Okay, so this function is odd or even, you have to see. So f of minus x will be what? F of minus x will be ln under root minus x ka whole square will be x square only. So I am writing it directly. Okay, so if you add these two, the two functions will be 0. So odd function it will be there. Add these two, the function is going to be equal to 0. F of x and summation is going to be equal to 0. Okay. Yes, if this function is symmetric, if the graph of the function, this is symmetric about the y-axis. If the graph is symmetric about y-axis, then f of x has to be equal to f of minus x because the function is an even function. Okay, so f of x is already given to me like this. So f of minus x will be what? F of minus x will be a ki power minus x minus 1 upon minus x ki whole power n into a ki power minus x plus 1. The moment you do this, so n has to be a negative number. N has to be an odd number. N has to be an odd number. Then only the thing will be satisfied. So D for Delhi will be the answer. You can see it. Just equate these two, you will get to know. Take the LCM in a ki power minus x and so on. The problem will be solved. Even plus even is always an even function. Even plus odd is neither even nor odd function. Like for example, if you talk about this, so cos x plus x square. Okay, if you talk about the second one, you can say that it is x plus x square. Okay, you can say x ki power 4 plus x, you should take it like this. Okay, over here you can take x plus x square, not an issue. Over here you can take sin x plus tan x, right? These are the examples given to make you understand. Similar examples are there. Even minus even is even function. Even minus odd is neither even nor odd. Odd minus even. Odd function minus even function is neither even nor odd. Odd function minus odd function is odd. Okay, let's say this is an even function, isn't it? And this is also an even function. So even plus even will be what? Even only. So this entire function is also even. That's it. Talking about this is an even function. This is an odd function. So it is neither even nor odd. Neither even nor odd. Talking about this is an odd function. Okay, and this is what? Cot of. This is also an odd function. Odd minus odd is what kind of a function? Odd function, right? Okay, the only function which is odd as well as even at the same time is nothing but f of x equal to 0. That is I hope you guys are clear. Even into even is always even, even into odd is odd, even into odd into even function is odd function. If I tell you the example, then the example can be x square into cos x. Here it can be cos x into x. Here it can be x into sin x into cos x. And for the last one, the example can be x into tan x. Okay. Yes, similarly in the division as well, I hope you guys can be comfortably see this. Okay, this is odd, so odd into odd will be even. Similarly, this is odd, this is even, so odd into even will be odd. The square of any even or odd function is always going to be an even function only because the minus sign will be removed, yes or no? Okay, this you guys can do as part of homework. There has to be no issue at all. And you have to check whether this is odd or even. So any function can be written as a composition of sum of odd and even functions like this. So this is one such property. Periodic function, if a graph is getting repeated after a certain interval, like if you take the graph of y equal to sin x, so this graph will be repeated again and again and again, beta. Yes, this interval is 0 to 2 pi. So the least fundamental value for sin x for getting repeated is 2 pi. That's why 2 pi is called as the fundamental period. If you look at the graph of tan x, then the graph of tan x will be looking something like this. This is pi by 2 and this is minus pi by 2. So the same graph is repeated again and again and again. So over here, if you see, the graph formed will be like this. This will be 3 pi by 2, like this. So over here the fundamental period is pi. Okay. Yes, so that is the case. Let me tell you few algorithms and then the thing will be done. These are a few graphs. Okay, yes, these are the few important rules. The period of sin ki power nx, cos ki power nx, sec ki power nx, cosec ki power nx, whenever n is even, the period will be pi. That is, if I ask you what is the period of cos to the power 100x, the period will be pi. If n is odd, let's say I ask you cos to the power 51x, what is the period? So period will be 2 pi. If I'm talking about any power of tan and cot, if power is odd or even, it does not matter, the period will be, fundamental period will be pi only. If there is modulus on any of the trigonometric ratio, then the fundamental period of that function will become pi. The fractional part ka periodic function, the period is 1. Algebraic functions are non-periodic in nature, like polynomial functions, they are non-periodic in nature. Constant function is periodic, but fundamental period is not defined. Constant function like this is a periodic function because you don't know how much interval is getting repeated, right? Okay, so a function may or may not be periodic, like this is an algebraic function, this is not periodic. This is also algebraic function, not periodic. This is modulus function, not a periodic function. Okay, yes, let me tell you a few rules. If let's say you know period for f of x and the f of x is having a fundamental period t, and I have told you to find out the period of some constant into f of x, so same period it will be. So the functions sin x, 2 sin x, 3 sin x all have same fundamental period, and that is 2 pi. Second thing, if you know that f of x has a period t, then f of x plus minus constant has the same fundamental period. Jaise y equal to sin x ka period you know 2 pi, so y equal to sin x plus pi, the sin x is different, okay, then the period will be same. For sin x minus 10, the fundamental period will be same. It does not matter plus constant or minus constant, the fundamental period will remain same. So ultimately, if something is added, subtracted, multiplied or divided in a function, the period will remain same. Like over here you can see, if x has been replaced by x plus b, like this. If x has been replaced by x plus minus some constant, then the period will also remain same. This time inside plus is written. Earlier sin x, on the sin x there was bracket, so period will remain same. Only in this case the period will change. If x has been replaced by d into x, then the period will be t by modulus of d. Like the period of sin x is 2 pi, then the period of y equal to sin 2x will be what? 2 pi over 2, that is pi. The period of sin of minus 8 will be what? 2 pi over mod of minus 8, that is 2 pi over 8. 2 pi over 8 is pi by 4. I hope you understood this. Only case in which period changes. Only case in which period changes. Yes or no? I hope you people understood this. Anyone is having any difficulty in this? so feel free to reach out to me. So look, if a function f of x ka fundamental period you guys know that it is t, then a times of f of dx plus b plus minus c, anything has been done, then the period will be this only. Because x has been replaced by some linear expression, so period will only change as the coefficient of x. For constant function, the fundamental period is not defined. Okay, then if f of x and g of x are two functions with the periods t1 and t2, and I have told you to find out the fundamental period of this one, then you have to take the LCM of t1 and t2. This may not be a fundamental period. If let's say you have been told to find out LCM of rational numbers, then you have to take LCM of the numerators and then divide it by HCF of denominators. You will get the thing. LCM of irrational with irrational is only possible when the irrational numbers are of same kind. Like these two numbers are not of same kind, so the LCM does not exist, but pi and 2 pi are of the same kind, that's why LCM exists and it is equal to 2 pi. Okay, LCM of a rational number and irrational number does not exist. Okay, like over here the period will be 2 pi, over here 2 pi, over here 2 pi by 3, yes or no? Over here also 2 pi by 3, can you guys feel it? Okay, over here 2 pi by 5, over here 1, over here 1, over here 1, yes or no everyone, do let me know. Over here if you see 1, over here 2 pi, over here pi, and over here also pi. Yes. Okay, over here non-periodic, over here non-periodic logarithmic functions are non-periodic pi. Okay, over here if you see the period of this is 2 pi, LCM of 2 pi will be 2 pi. Okay, 2 pi and pi LCM will be 2 pi. ठीक है, this is pi by 2 and this is 2 pi by 5, so LCM of pi by 2 and 2 by 5 is what you have to take. So pi तो ले लिया, फिर then you have to take LCM of 1 by 2 and 2 by 5. I hope you can do it. LCM of 1 and 2 and HCF of 2 and pi, so this is 2 pi. Okay, then over here the period is pi, over here the period is pi by 2, over here the period will be pi by 3. So LCM of these three numbers will be what? Pi only. Right? Whenever we have complementary functions like sine, cos, tan, cot, sec, cosec with modulus or with same even powers, the fundamental period will be the half of what we are getting from the previously learnt method. So look, over here the fundamental period was pi, over here also pi. So LCM of pi and pi will be what? Pi. But the answer is not equal to pi in this, rather the answer is half times of pi. So the answer is pi by 2. Why? Because same complementary functions tan and cot are written with modulus or with same even powers, then half se bhi multiply we need to do. Over here same even powers are there, so over here the period will be pi, over here also the period will be pi, so the LCM is coming out to be pi, but the answer will be half times of pi, that is pi by 2. I hope you guys are clear with this. Okay, over here the period will be pi, over here the period will be pi, but the answer will be pi by 2 because these are complementary functions. Over here the period will be 2 pi by 5, 2 pi by 5, but the answer will be pi by 5. Half of that. Over here the period will be pi by 3, but the answer will be pi by 6. Because these are complementary functions. Okay. Sine of cos of sine x, I think you guys can do this. The period of this will be what? 2 pi so has to be, because it is the period of cos x. But talking about the half of that, the period will be 2 pi. Okay, over here if you see the period will be 2 pi, but over here the period will be pi only, because cos of minus theta is how much? Cos theta. So I hope you know this. That's it from the functions portion. I hope that whatever I have taught you in this today's session, you have understood it and you're gonna nail the topic from now onwards, because before moving into class 12th, it's very important that you master this class 11th topic relations and functions, because entirely class 12th will be solely based on this only. So I hope that this session have helped you. See you in the next session. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much. Bye bye. Take care. Happy learning.